Hi everyone, welcome to our seventh lecture of CSC 110. This lecture is a continuation of our lecture on encoding, but in this lecture we're going to actually start doing much more practical problems, and we're going to start asking questions like how much information can you put on various storage units, like a 64 gigabyte USB drive, or hard drives, which are the drives inside of laptops and inside of the storage units inside of laptops or inside of desktops, or even on your phone, because even your phone has a storage unit. Okay, and the storage unit on a lot of phones is like 64 gigabytes and something like that. Okay, so what does that mean? What does it mean to say you have a storage of 64 gigabytes? And along with that, the sizes of files. Okay, so we're going to say, this audio file, how big is it? Yeah, this movie, how big is it, and so on. And how many of these movies could you fit on your phone? How many of these songs could you fit on your phone? And questions like that. Okay. Also, we're going to be looking at data rates, and data rates is like how fast can you transfer some information over the internet or over your phone line or whatever the transmission medium is. Okay, so you go and you get like say Spectrum's lowest rate package. You might ask for your home internet, and you might ask the question, well, how fast is this? And I don't know what their smallest is, but like they have like a typical size is something like 100 megabits per second. Okay, so you might ask the question, well, how fast is 100 megabits per second? How long would it take me to download a movie? Something like that. Okay, and so those are the kinds of questions that we're going to be asking. It follows on encoding, because encoding tells us the sizes of files, but now we want to ask how much, like we want to get a feeling for how big those files are with respect to the storage units that we have. Okay, and I should just say one thing: our storage units have gotten so big right now that the amount of information you can get on them is a lot, and it's really hard to fill up the hard drive of your laptop or your computer. You can do it if you put enough movies on there. You certainly will fill up your hard drive, but on the phone, people hit limits pretty quickly. Okay, so this is good to know. Just how much information could you get on your phone, something like that. Okay, now before we jump in and start doing data size and data rate problems, we have to be able to convert our metric prefixes. Okay, so I already gave you this, but we need to now make this a very easy and natural way of converting between units, because in our word problems, what we're going to do is I'm going to give you the word problems, and I'm going to expect you to convert as part of them. Okay, so you're going to have these larger word problems, and if unit conversion is an issue for you, then it makes the word problems all the harder. Now, the word problems themselves the math is not that hard, but you got to understand the concepts, and that's really what this class is about. Okay, so the metric prefixes in computers, like kilo, remember I told you that a kilo is actually defined as 2 to the 10 in computers, okay, in computer science. So 2 to the 10 is like 1024. But in this lecture, and from this point on in the course, we're going to do that approximation that I gave you, and that is kilo will simply approximate as 1,000. It just makes the math so much easier. Okay, and it's very close: 1024, 1,000. What's 24 bytes in there? Okay, so so you should have this chart memorized, and I should say that the chart starts off with small units up here. Okay, so these are the small units here, and it increases to the larger units down there. Okay, so how does this work? Okay, so a byte is, it's not the smallest data unit. A bit is the smallest data unit, 1 or 0, but it's the smallest data unit that's used in practice when we measure like the size of a USB drive. We don't say the size of a USB drive in bits. We say what the size of a USB drive is in bytes. Okay, and so you go out and buy one of those USB drives, and it says 64 gigabytes. Okay, now when it comes to data rates, that's done in bits, but for the data size problems, the first few problems that we're going to be doing, that's going to be in bytes. Okay, and so here I've got the chart in bytes. So a kilobyte, again, technically 1024, but we're going to be approximating a kilobyte as 1,000 bytes. Okay, so 1,000 of the smallest unit, byte, gives you a kilobyte. So kilo just means 1,000. If I say 1,000 bytes, or I say a kilobyte, I'm saying exactly the same thing. Okay, it's like saying 12 eggs or a dozen eggs. All right, go to the store, you say, I want a dozen eggs. Okay, or you go and you ask for, I want 12 eggs, you get the same amount. You have some file and you say this file is 1,000 bytes in size, or you say it's 1 kilobyte in size, you've said exactly the same thing. Okay. And each level, each metric prefix goes up by a factor of 1,000. Okay, so starting again at the bottom, 1,000 bytes is a kilobyte. Then 1,000 kilobytes is a megabyte, and then 1,000 megabytes is a gigabyte, and 1,000 gigabytes is a terabyte, and 1,000 terabytes is a petabyte. It goes on past that, but that's enough. That's enough for our course. Okay. Maybe in the future, if Moore's law keeps continuing with hard drives, because Moore's law doesn't just apply to it applies a little bit to hard drive and storage as well. Okay. So these your drives are able to, the physical size stays the same, but they're able to hold more and more information as time goes on. Okay, but I think a petabyte is probably going to be the limit of what you'll see, in the near future at least. Okay, I can't tell what the far future is. All right, so just notice that every time you go up to the next unit, you go up by a factor of 1,000. So another way to think about this is, if you've got a megabyte, okay, think of it as 1,000 kilobytes. But we could actually go down one more level and say, well, if a megabyte is 1,000 kilobytes and a kilobyte is 1,000 bytes, then a megabyte is 1,000 bytes, or 1,000 times 1,000, or 1,000,000 bytes. Okay, so if you go down 2 levels, it's just like 1,000 times 1,000. If you go down 3 levels, it'd be 1,000 times 1,000 times 1,000. Okay, so let's do that. Like, how many bytes? If I ask the question, how many bytes are in a gigabyte? Well, then you would say something like this in your head. You'd say, well, a gigabyte is 1,000 megabytes, but a megabyte is 1,000 kilobytes, but a kilobyte is 1,000 bytes, and so a gigabyte is 1,000 times 1,000 times 1,000 bytes. Okay, and we're going to be doing some problems like this. So let's do those problems, and then hopefully that'll help out. Okay, so here's our first problem. Okay, really simple. Just convert 1 gigabyte to megabytes. Okay, so that's easy. Why? Well, because you just look it up in the table. Right, it's right here. There it is. So 1 gigabyte is equal to 1,000 megabytes. So the answer to the first question, that's the answer. All right, write that. Okay, let's just put that in there. All right, so a gigabyte is 1,000 megabytes, and that answers the question. Okay, I made that one trivial. I just wanted to show you how the table works. Okay, now what if I said convert 1.5 gigabytes to kilobytes? Okay, well, I did tell you that 1 gigabyte is the same as 1,000 megabytes. Okay, you say, where'd you get that? That's right there. Okay, and 1 megabyte is the same as 1,000 kilobytes. And so we need to combine these two statements together. Okay, and I'm going to show you 2 ways of doing this in a minute, but let's just try to think of it intuitively first. Okay, so you've got these 2 statements. You got 1 gigabyte is 1,000 megabytes and 1 megabyte is 1,000 kilobytes. Well, then you can combine the two and say, well, then 1 gigabyte is 1,000 times 1,000 kilobytes. Okay, so what did I do there? Well, you can see that this megabyte here, I just put that in brackets there like that. Okay, so I have 1,000 units of 1,000. Well, what do you mean when you have 1,000 of 1,000? You mean multiply. Okay, and so if I multiply those out together, what I'm going to get is that 1 gigabyte is equal to 1,000,000 kilobytes, like that. Okay, and let me put some commas in there so it's a little easier to see. All right, and so you can see that now I've got the statement that 1 gigabyte is 1,000,000 kilobytes. We haven't quite answered the question. What we did was we first dealt with the units, converting between giga and kilo. Okay, now if we say, look, 1 gigabyte is 1,000,000 kilobytes, well then 1.5 gigabytes has to be 1.5 million kilobytes. Okay, and you could do that like this. I could multiply both sides by 1.5. Okay, and I've got 1.5 times all of this, and then of course you get that 1.5 gigabytes is equal to 1,500,000 kilobytes, like that. Okay, that answers the question. All right, now I'm going to show you a different way of doing this. Okay, and I don't want to be too pedantic, too simplistic, okay? But the thing is that when we get to more and more complicated units, especially when we start to add time into the mix, when we get into the rates later in this lecture, you're going to want to say, oh, wait a sec, how do I make this conversion between days and seconds? Okay, and you'll have to think it out, and I want to show you a method that is a foolproof method for actually doing this unit conversion. Okay, so starting again, so this is like me starting over here. I'm going to say, well, look, I need to convert between gigabytes and kilobytes, okay? And so I'm going to have to use these two lines right there, okay? Let's start off actually with just this one right here, the giga to mega, all right, like that. So we need to make that conversion right there, okay? Well, if you've got that the left-hand side is equal to the right-hand side, then effectively you could divide both sides, the left-hand side by the right-hand side, and that number must be equal to 1. Okay. Now, what do I mean by that? Let me just take a little bit of an aside here. Suppose that I have 5 is equal to 5. I know that's absolutely trivial. Okay, 5 is equal to 5. Well, one way to think about what you mean by 5 is equal to 5 is that if you take 5 and you divide by 5, in other words, you take the left-hand side and you divide it by the right-hand side, that's equal to 1. That's kind of what we mean by equality. Okay, and if I had 7 equals 7, true, then 7 divided by 7 is equal to 1. Or you could just go on, like you could make this into like algebra. A is equal to B. If A is equal to B, then A divided by B is equal to 1. Okay, provided A and B are not equal to 0. Okay, but let's not worry about that corner case. Okay, but the opposite is also true. Not only is A divided by B equal to 1, but you could also say that B divided by A is equal to 1. Okay, and so whether you take the one side and divide it by the other, you get 1, or vice versa, you still get 1. Now, what's nice about 1 is you can always multiply by 1 and you don't change the value of something. Okay, now you'll see what I'm going to do with this in a minute, but let's apply this. Let's apply this right here to that equality there. That tells me that I can make two fractions. I can make the fraction 1 gigabyte divided by 1,000 megabytes. That's going to equal 1. Okay, that's like your A divided by B. And the other one is going to be 1,000 megabytes divided by 1 gigabyte. That's also going to equal 1. Okay? And so we have two ways of expressing the number 1. All right? And where am I getting that? I'm getting that out of this table. So this table, even though I expressed it in terms of equalities like that, left-hand side is equal to the right-hand side, you can also think about it in terms of fractions. Okay, where the top and the bottom divided by one another give 1. Okay, now that takes care of the gigabyte to megabyte conversion. What about this one? Well, that one also gives us two fractions. Okay, and here they are. Okay, one fraction is 1 megabyte divided by 1,000 kilobytes is equal to 1, and the other one is 1,000 kilobytes divided by 1 megabyte. That's also equal to 1. Okay. Totally trivial, I know, but nonetheless, we have those four fractions there. Okay, so we got these two possibilities for the gigabyte to megabyte transformation, and we've got those two possibilities for the megabyte to kilobyte transformation. Now take a look at what we're trying to convert. We're trying to convert 1.5 gigabytes to kilobytes. Okay, so let's start with that number right there. Okay, we can even say that our answer is equal to that. Okay, well, that's not quite the answer, but at least in value it's equal to that. Okay, and now you say to yourself, but I don't want gigabytes. I want to get rid of the gigabytes. I want to eliminate the gigabytes. And so you could take a look at these four fractions, and you'll notice that obviously just the first two have gigabytes in them because they're the ones that convert the gigabytes to megabytes. And you go, all right, I want to eliminate the gigabytes and replace them with the next smaller unit, the megabytes. Okay, eventually we'll want to get to kilobytes, but for the first step we want to go from gigabytes to megabytes. And you take a look here and you go, well, if I multiply by this fraction, we don't really eliminate the gigabytes because the units work just like variables. And you can take a look here, just concentrate on the gigabytes. There's gigabytes here, and there's also gigabytes right there. Okay, so gigabyte there and gigabyte there, but they're both in the numerator. Okay, because this is forming a fraction. So here's the here's the division between the numerator on top and the denominator on the bottom. So there's the fraction. This particular fraction puts 2 gigabytes in the numerator And that's no good because then you get gigabytes squared. It doesn't eliminate, it doesn't cause the gigabytes to cancel out. And so you say, well, but I have this other fraction, so rather than using this one, how about we use this one? Okay, and so we'll copy and paste that one in there. All right, and now you go, aha, look at that. I've got here gigabytes in the numerator, and here I've got gigabytes in the denominator, and they're going to cancel. Okay, and so when I multiply this out to get the next line of my thing, and when you get good at this, you're probably not going to you're not going to be doing it this way. But let me just show you step by step. Let's do the numbers first. So here I've got 1.5 and I multiply by 1,000. And 1.5 times 1,000 is 1,500. Okay. Now here I've got a gigabyte, a megabyte divided by a gigabyte. So that's going to give me a gigabyte times a megabyte divided by a gigabyte. Okay. And you take a look at that and you go, oh, the gigabyte here in the numerator will just cancel the gigabyte there in the denominator, and I get that. Okay, so what we've effectively done is we've made use of that fraction. Remember, you can always multiply by 1. So you say, well, why did you just put that in there? That highlighted fraction in brackets, that's equal to 1. And you can always multiply by 1 and you don't change a value. Okay, and so we went from the gigabytes here to the megabytes there. And you say, all right, I'm not done because I asked you to convert to kilobytes. And you go, well, how about I do this again? So you got megabytes, you want to eliminate the megabytes and you want to replace them with kilobytes. So again, you want the megabytes in the denominator. So you want this particular fraction. You've got two choices, that one or that one. They're both equal to 1. You can always multiply by 1 and you won't change your answer. But you want to use this particular form of the fraction because that's the one that's going to eliminate the megabytes and give you kilobytes. So now, just do this very quickly. The megabytes here will cancel the megabytes there, and the only remaining unit will be kilobytes. And so you'll get the kilobytes, all right, for your unit. Once again, the megabytes there cancels megabytes there. And the only remaining unit is kilobytes. And then you say, well, what about my numbers? Because that's just the unit. You do the units separately from the numbers. You could do either one first, but you just deal with each one separately. Okay, so we dealt with the units. Megabyte times a kilobyte divided by a megabyte. Megabytes cancel out. You get just a kilobyte. And now we've got the numbers. We got 1,500 multiplied by 1,000, like that. And when you multiply that out, you're going to get 1,500,000, like that. Okay, and let me put the commas in there so you could see it. Okay, that's why we put commas in these numbers to make it easier to read them. And there's your answer. Okay, and so you could write so 1.5 gigabytes is the same as 1,500,000 kilobytes, like that. All right, great. Let's do one more. And we'll just use that second technique because it's the easier technique to use. We have here terabytes and we want to go to megabytes. Okay, and so you say, okay, great. I need a fraction here that's going to equal 1. That fraction has to have terabytes in the denominator. I'll put in the numbers in a minute, so I'm going to do the units first. So I don't know what number I'm going to put in there, but I want to go from terabytes and I want to go to megabytes. Okay, like that. And you say, all right, well, what number should I put in here and what number should I put in there? Okay, well, if we go back to that table, we could try to do this all in one shot. Okay, so we from the terabytes, so here we are in the table, from the terabytes to the gigabytes, it's 1,000, and then from the gigabytes to the megabytes, it's another 1,000. Okay, and we want it to go all the way to from terabytes to megabytes. Okay, so from the tera to the giga is 1,000, and then from the giga to the mega is another 1,000. And so we can skip a little step there and just say 1 terabyte is equal to 1,000,000 megabytes, like that. Okay. So if that was a little bit too fast, let me just repeat for you what I did there. It's these two lines, like that. Okay, those are the two lines that we're converting. And line them up. And tera to giga is 1,000, and then there's another 1,000 there. If you say, well, I don't want to do the 2 steps, okay, I don't want to do 1 step. Let me just do it as 2 steps. You could do it this way. Instead of going right to a million, you could say, okay, well, I got to go from tera, and the next one down is giga, like this. And then you say, okay, well, 1 terabyte is equal to 1,000 gigabytes, like that. But that doesn't get me all the way down because I got to go down 1 more step to megabytes. And then you can say, okay, well, let me make another fraction here. And there's got to be a top and a bottom. All right, so the denominator, the bottom number, has to cancel out the gigabyte. So we need gigabytes in the denominator. And in the numerator, we need whatever that's equivalent to in megabytes. Okay, because we want to convert to megabytes. And so 1 gigabyte is 1,000 megabytes. So 1 gigabyte is 1,000 megabytes, like that. And you could see that what happened here is that if I combine these two first, I'm going to get 1,000 times 1,000. That was the million you saw just a minute ago. All right. And we're going to have the gigabytes cancel out because there's a gigabyte in the numerator and a gigabyte in the denominator, and so they'll cancel out. And then you'll just get a megabyte in the numerator. Okay, notice that megabyte doesn't cancel out. And there'll be a terabyte in the denominator. 1 terabyte in the denominator. And that's what I wrote just a minute ago. Okay, so I just wanted to show you, you could do it either way. Okay, it's just usually when you get good at these things, you're going to look at these two and go, oh, I have to do 2 steps. From tera to mega, I got to do 2 steps. Well, 2 steps is 1,000 times 1,000, which is a million. And you could just write that in there right away. And then you just multiply everything out. The terabytes cancel, so we'll do the units first because they're the more interesting part of this number. The terabytes will cancel out, and you'll be just left with a megabyte there, like that. All right. And then you've got 53.5 multiplied by a million, like that. And then that'll give you your answer. 53,500,000 megabytes. Okay. All right. So 53.5 terabytes is the same as 53,500,000 megabytes. All right. I'm not going to do any more unit conversion problems because by themselves, they can get a little tricky, but not that tricky. Okay. So let's continue and let's start now looking at data size problems. Okay, and just to remind you what these data size problems are, they're going to be questions like how many files can I get on of a certain type? How many files of a certain type can I get on a USB drive? How many files of a certain type can I get on my phone? Okay, now there's a couple of reasons for doing this. One of them is you might have to do that calculation in real life. Okay, like digital x-rays. How big are digital x-rays? I don't know, but they're probably in the gigabytes. Okay, and you've got some storage unit. You want to say, well, how many of these digital x-rays can I get on the storage unit, this hard drive on this machine before it fills up? Okay, so the x-ray machines in diagnostic centers, they have a computer behind them because everything has a computer behind them today. Okay, and so when they take those x-rays, they got to store them. And eventually you got to throw away those x-rays because you're going to fill up the storage space, and you might ask the question, well, how many x-rays can I get on here before I have to start throwing away older x-rays to make up more space? Okay, that's the kind of questions we're going to ask. So that's one reason, just a very practical reason. The other reason is, if I said to you 1 gigabyte of information, how much is that? Is that a lot? Is that a little? Is 1 kilobyte of information a lot or a little? Like it's hard for your mind to get a sense of how much information is in there. And I mean qualitatively, like a sense of how much information is in there. And we have a good sense of like distances. Okay, so if we measure like a distance and I say, look, my finger is about 1 centimeter wide. Okay, you know what I mean by that. You got an idea of what 1 centimeter is. So you could go, okay, yeah, I can see how a finger is about 1 centimeter wide. Now, a meter is, I can't even show you a meter on the screen there, but a meter is like 3 feet. And if I said to you, my finger is 1 meter wide, you go, no way. No, it just isn't. Now, why? Why do you know that? Because inside your head, you got an idea of how big a meter is, and you got an idea how big a finger is, and you can go, well, they're just not at all the same. Okay, they're not at all the same size. And so internally, you have an idea of sizes. You even have an idea of like distances. Okay, if I say, Niagara Falls, New York is 30 miles away. You got an idea what that means. You got an idea what that means, okay? But do you have an idea of how big 5 megabytes is? Do you have an idea how big 1.5 terabytes is? 4 terabytes? Okay, do you have an idea how big a petabyte is? You see what I'm saying? So you don't have necessarily a good idea of how much information we're talking about here. And hopefully by the end of this lecture, you'll have a much better idea of just what those numbers mean. Okay, you buy that 64 gigabyte USB drive, and it's kind of small. You carry it in your pocket, and you're wondering, well, how much information can I get on this thing? Well, what if I told you you can put a whole library on that? You go, what? A whole library can fit on this thing? Like, really? Yeah, because you don't necessarily have a good sense of how big 64 gigabytes is, okay? Or maybe I could tell you, you got, you could put 16 movies on there, 16 full-length movies. Okay, like if a movie's 2 hours of viewing, they're usually an hour and a half, 2 hours. Like a full, blockbuster video. Okay, and you say, well, how many can I fit on? There's 16. That's like 32 hours of viewing. That's 32 hours can fit on that. Okay, so now you're starting to get a sense of how big we're talking about, how big these sizes are. Okay, and that's the point of these problems. All right, so that's the kinds of problems we're going to be doing, and there's I wouldn't call it a formula, but there's just a general idea behind these, how to solve these problems. And a lot of these problems I'm going to be asking, how many files of a particular type can you fit on the device? Okay, so how many movies could you fit on this USB drive, like what I just said? Okay, and generally the way you answer that question is you say, whoops, I've got this. Yeah, no, I got it right. Okay, I thought I had it upside down. It's a fraction. Okay, so how many files can you fit on a device? It's a fraction. It's basically how much space is on that device. And we should say free space because there might be other files and that they'll take up space. And so there'll be some space left over. So how much free space is left on your device, okay? Later in the course, I'm going to show you how you can ask that question of your computer, okay? I'll show you how, like, on a Windows machine, you can actually look at and find out how much space is on a device, okay? There's a way of doing that, all right? So, that's the numerator, and then you divide that by the size of one file of a particular kind, okay? So, it's kind of like a pie problem. So you've got a pie, and you want to say how many slices of a particular size can I get out of this pie? Okay, that's the kind of questions. I think it's pretty intuitive, all right? Now, to answer this question, you got to know the sizes of files, okay? And, whoops, cut it off here a bit. So you need to ask the question the size of the files. And I gave you this chart when we were doing encoding at the very end of that. We're going to pick up from that. This chart is an approximation. It's typical sizes of files, okay? Now, the reason you can't say necessarily exactly how big a file is because you remember this business of encryption? Not encryption, and compression. So what compression is it makes a file smaller. It throws away a little bit of the quality of the file, but it makes the file smaller, okay? Now, you say, well, I don't want to throw away any of the quality of my file, but it may not matter as far as you as a human being go because, your eye can only absorb so much information. So as you make the file smaller, okay, you are throwing away information, but you're throwing away information that may be imperceptible to your eye, okay, because you can only see so much, you can only absorb so much, okay? And so the trick is compress it to the point where if you compress it any further, you notice. If you can't notice that it's been compressed, then what difference does it make as far as a human goes? Now, I say human because a computer could also look at the same file, can also analyze the same file, and see things that you as a human may not be able to see. Okay, like I'm thinking here of the analysis of a X-ray image by a computer. A human being, a doctor, could look at that X-ray and go, oh, it looks like there's a little crack in there, or something like that. But a computer might say, oh, there's not only that little crack there, but there's also this other little micro crack that you didn't notice because you're just a human being and you can only see to a certain level of resolution. Okay, so you may not want to compress beyond a certain limit for computers, but if the file is just for human consumption, like viewing an image on a web page, well then compressing it, may make no difference to the human eye at all. Okay, and if it doesn't make any difference to humans that are going to be looking at this image, why bother keeping all this extra resolution? Okay, now because of this compression, I can't necessarily tell you how big a file is, because you might want a super high quality file beyond human ability to see, but this chart is just roughly how much information is in various different types of files, and we'll be making use of this chart. Okay, so let's take a look at it, and I think you'll see what I mean here. So the first type of file is images. Okay, so these are images that you would see, like, a picture on your screen. Okay, now pictures can be really high quality or they can be low quality. All right, most of the images on a web page are low quality, and the reason you want a low quality image on a web page is because you want it to download quickly, and then you know how long you spend on a web page, just seconds. You just scan the page, and no one's going to look and see the little bit of defects that the compression added in. Okay, so again, this is an approximation, but roughly speaking, these low quality images are about 100 kilobytes each. Okay, so if I asked you, how big is a typical low quality image on a computer, it's about 100 kilobytes of information. Okay, so just to remember what that means, it's 100 times 1,000 bytes, or 100,000 bytes, or we'll say 100 kilobytes. Okay, now images are one thing. The other thing is video. All right, like a movie or something like that. And roughly speaking, 2 hours worth of movie information is about 4 gigabytes in size. Okay, now remember, kilobyte, the next bigger step up is megabyte, and then the next step up is gigabyte. So a movie is much, much bigger than an image. And that makes sense, because think about what a movie is. It's one image after another. Okay, so you got like how like you can make cartoons out of like one image and then another image and then another image, like frames, still frames. Okay, but if you throw about 30 frames at a human being per second, 30 frames per second, like 30 images per second, it starts to look smooth. Okay, 60 frames per second, you can't tell whether it's a bunch of individual images or actually continuous movie. Okay, so you can think of a movie as a bunch of images, but it's more than just that. It's not only just images, it's also sound. Okay, and so there's a lot more multimedia information inside of a movie. And typical, like DVDs are going out of style. Okay, but like in the ancient days, they had these DVDs, and you could watch movies off of DVDs on your DVD player. And then they have Blu-ray, and Blu-ray's going out of style, because all of those medias are going out of style because of the internet. Okay, you just download your movies and then throw them away after you've watched them. Why store them for a very long time? Okay, so typically a video, like a 2-hour length movie, is about 4 gigabytes in size. This is good quality. Okay, that's why I say DVD quality. Today we might just say good quality. Okay, because DVDs are disappearing. Okay, I should just say something a little bit about Blu-ray. Blu-ray was kind of going to be the next step after DVD. The only reason it was introduced was purely for marketing reasons. They said, look, this is so much better quality. It was, but you can't see that better quality. And the other thing is that they were hoping that Blu-ray encryption was not going to be crackable, so that you couldn't copy the movies off of the device. DVD encryption was cracked right away. Okay, it took seconds to crack it. Blu-ray was crack means like ability to remove the information from the device so that you could share it on the internet. In other words, piracy. So they wanted to prevent piracy by encryption. Okay, and Blu-ray had better encryption, but the thing is they cracked it within a couple of years, and so it's like, well, and then the movie industry just wanted you to buy these things. They sold it as better quality, and it was better quality, but it wasn't perceivably better quality. You wouldn't appreciate the better quality unless you're projecting this movie on like to a big screen. Well, then maybe, yeah, but just for general like viewing, people are willing to watch even lower quality than DVD quality movie, and so that was that's not the reason why they were pushing it. They were pushing it because they were hoping people would adapt this new technology and it would prevent piracy, but it didn't, and that's all gone away anyhow, because how do you get your movies now if you even want movies? I mean, most people just watch stuff on YouTube, right? That's what you're doing right now. You're watching stuff on YouTube. So, people generally will just download the movie, or they'll watch it in real time, which is a kind of a downloading, okay? In other words, you don't have to store it on the file. You can watch it and then throw it away as you're watching it, and that's the same thing as streaming. So, at that point, like, why bother with carrying these discs? And that's why these Blockbuster stores, they all went out of business, because no one was physically walking to rent a DVD. Okay, you just download them from the internet. Our internet speeds are fast enough. Okay, enough of that aside. Audio, sound. Okay, generally for 1 minute of good quality sound, it's 1 megabyte. So 1 megabyte per minute. Okay, like if you have a song, and usually songs are 5 megabytes in size, that might be five minutes in long. So you have a song which is 5 minutes long, that would be 5 megabytes. Okay, if you're recording a lecture, and on your phone or on some MP3 recording device, generally you could say for every minute of lecture you're going to be storing 1 megabyte. Okay, 50-minute lecture, 50 megabytes in size. Okay, and you could see that megabyte is kind of in between the image. Audio is kind of in between the image and the video. Okay, so you got here an image in the kilobyte range, an audio 1,000 times bigger in the megabyte range, and then a video 1,000 times bigger yet in the gigabyte range. Okay. And then finally, the other ones you should know are documents, and these are just like text files. Okay, but I gave you three here. There's three because generally speaking, there are three different types of text files that you'll use. The lowest quality are just plain old ASCII or plain text. Okay, so if you ever hear something called plain text or ASCII, what that means is it was made by Notepad. That's it. Okay, I don't have Unicode in there. I could have, but that's okay. We'll just do like plain text. Okay, so what you're actually seeing right now, this like all my notes that I have highlighted there. This isn't Notepad. I'm using another operating system called Linux, which I'll tell you about later. It doesn't use Notepad, but still, it's just a text editor. You'll see that everything in here is just basically ASCII. Okay. All right. So an ASCII, one page of ASCII is about we're a document, but of course documents like per page, because they could be like a 5-page document, a 20-page document. Okay, per page it's 1.5 kilobytes per page. Okay, of plain text, and usually these files have an extension, so they have like a name. Like on your computer, you'll see them on the name, and then there'll be a dot, and then there'll be an extension. The extension will be something like txt, okay? And anything that ends in txt is usually considered an ASCII file. All right. Now, one step up from that is a doc file, okay? And that's like a Word document, or we'll study later. I'll show you LibreOffice. LibreOffice and Word are very similar to one another, but LibreOffice is free, which is what I want to show you, because there's a lot of free software out there, and you don't have to go out and buy software anymore. Okay, so when we get there, I'll be teaching about LibreOffice and so on. But there's these are files that have an extension docx. Okay, now because there's more information than just the letters. So there's the letters, but there's the information about the font and the size and whether it's bold or italic and all this extra information, or whether it's centered or underlined, or there's highlighting. You can actually make your letters different colors and so on. So whether depending on all that extra information, a typical size Word document file is 10 times bigger than plain ASCII. It's 15 kilobytes. Okay, and per page. All right. Again, this is an estimate, so you might have a file and you don't have a lot of extra like fonts or anything like that. It might be less than 15 kilobytes per page, but we'll just say that. Okay. And then finally, there are PDFs, and again, I'll show you what PDFs are and how to make PDFs later. But PDFs are also document files. They're the kinds of document files that are actually used for legal reasons. Okay, like if your bank gives you a bank statement, it'll usually be in a PDF format. There can be very high quality. So textbooks, that electronic textbooks are usually in PDF format. And like I have a lot of physics textbooks, and they have all those squiggly mathematical symbols like the integration sign and so on. You can do that in PDF. Okay, you can do that in PDF. You could do it sort of kind of in docx, but you need this extra program that helps to make the mathematical symbols. But that's really what this is for. And it also PDF, I'll show you later, PDF allows for encryption. And that is a way of securely sending information over the internet. I'll teach you about that. Okay, and it's also a way of doing electronic signatures. And you say, well, what's an electronic signature? To show that the document is really the document that you say it is. So for instance, imagine you get your statement from your bank. And what you're going to do is you're going to edit your PDF, and you're going to put a little extra zero in there to make it look like you've got more money. You're going to break that signature, and people are going to say this isn't the original PDF. You've faked it. Okay, so there's a way of saying, no, this is the authentic PDF, and it's exactly the way we wrote it, and nothing was changed in it. If you change anything, you're going to break the signature, and then you can tell. Okay, so these bank statements are they're electronically signed, um, and that electronic signature shows you that they are authentic, they're real, and they have legal status. Okay, so like you go to the, I don't know, you have a dispute with the bank. Maybe the bank took away a zero from your bank account, and you go, oh, that doesn't look right. And you go, well, this is the statement you gave me, and it doesn't look right. And, then you can actually prove that it is a real statement and not a statement that was faked. Okay, so anyhow, PDFs, their sizes vary a lot. It depends on how much information is in them. Now, I said in my estimation here, 100 kilobytes per page. The way I got that was I looked at some physics textbooks and it came out to be that. Okay, but for say just a plain old novel, it might be a lot lower than that. Okay, so just keep in mind that these are estimates, and the reason it's okay to work with this in just estimates is because most of this is just to practice this kind of reasoning. Okay, if you actually find that your PDFs have a lot less than 100 kilobytes per page, okay, but still the kind of logic that you're going to see and the problem solving that I'm going to do, it'll apply. Okay, so last thing, you'll notice that a high quality page in PDF is about the same size as an image. Okay, because that's where they get, like, at the extreme level, a book is just one image after another, an image of each page. Okay, so all right, now we can start doing some problems. Okay, so I've got here 4 problems. This first problem is in 5 parts. Okay, and this is the kind of typical problems that you should be able to do. Okay, so how big is a typical 40-page paper in docx format? So there's the question. How big is a typical 40-page paper in docx format? All right, so let's do that problem. So first of all, you have to identify that this is docx, and you can go, well, 1 page is going to be 15 kilobytes. Okay, and how did you get that for docx? Okay, all right, great. That's just 1 page, but we want 40 pages. All right, and so you could do, all right, well, then we got 40 pages. And what are you going to do? Well, you know what? You could even make that fraction that I showed earlier. You could say, okay, well, there's 15 kilobytes per page, like that. And so basically, the answer is going to be, oh, I've got to bring up my calculator here. It's going to be 40 times 15, and that is equal to 600. Okay, so it's 600 kilobytes in size, and that's the answer. A typical 40-page paper in .docx format is 600 kilobytes. All right, there you go. Well, that one should have been pretty easy. Okay, so there's our first question. All right, part B to that same problem is, how many such papers could you fit on an 8 gigabyte drive? Okay, now 8 gigabyte drives, that's like an older USB drive. All right, you say, well, how do I answer that? And it's this formula that I gave you at the beginning here. It's basically this. All right, this is the way you should be thinking about it. How many files fit should be the size of the free space on the device, okay, divided by the size of one file. All right, so whoops, you can't see that. Yeah, now you can. Okay, so it's the size of one file. All right, so size of the free space divided by the size of one file. Well, all right, it's a bit of an artificial question because you're not going to fill up an entire 8 gigabyte drive with just 40-page papers. But let's suppose we did, and this is to get an idea of like how many papers you could fit on one of the smaller USB drives. Okay, so how would you do that? Well, what's the free space in the device? Well, the device is 8 gigabytes, and I didn't say if it was all free, but let's assume it is. Later on, I'll show you how to do problems where there's already some files on it. Okay, so all right, so it's 8 gigabytes of free space. Okay, and the size of one file, well, we got that. Okay, one file was a paper, a 40-page paper, and we said that was 600 kilobytes, like that. And your answer is going to be if you divide that. Okay, the problem is if you look at that, you see that you've got a unit mismatch. Okay, the whole thing, the total pie is measured in gigabytes, and the smaller thing is being measured in kilobytes. Okay, and you say, well, what do you do? All right, well, either you have to convert the kilobytes to gigabytes or the gigabytes to kilobytes. Okay, one or the other. And I like converting the bigger unit to the smaller one. All right, so I want to get rid of the gigabytes and I'm going to replace them with kilobytes. And maybe we should just say, before I put an equal sign in there, let me just say what my strategy is going to be. Convert gigabytes to kilobytes so that we are not comparing apples and oranges, right? You can't like just divide this, all right, because you got gigabytes on top and that's one size, and you got kilobytes on the other bottom and that's a different size. You want the same size on top and on the bottom. All right, so you take a look at this and you go, okay, well, I got to go from gigabytes to kilobytes. All right, so back up to this metric chart up here. We want to go from gigabytes to kilobytes, and so we're going to need two lines from that, and so we're going to need these two lines here. Let me fix that up. Okay, we need both of those. All right, and I can show you, actually, let me just put the answer in here. Answer. Okay, I can show you what you how to do that in two steps. All right, so let's put brackets around this. All right, so the first step is going to be convert from gigabytes to megabytes. So we're going to be using this. Now the gigabytes are in the numerator, so we want the gigabytes in the denominator. And of course then we'll get megabytes in the numerator. Okay, and now we need some numbers in there to make this equal to 1, because it's not equal to 1 now. And you could just see that 1 gigabyte, so 1 gigabyte is equal to 1,000 megabytes, like that. And great, we've reduced the gigabyte one step down to megabyte, but we're still not done because we have kilobytes here, and the kilobytes are not going to cancel the megabytes. Okay, so we want to do one more step. We want to get rid of the megabytes. All right, and we're going to use this fraction here now. Okay, and so megabytes in the numerator here, we want to eliminate the megabytes. We want to eliminate the megabytes in favor of the kilobytes. Okay, so megabyte in numerator, megabyte in the denominator here, and they'll cancel. And 1 megabyte from this one right here is going to equal 1,000 kilobytes. Okay. Now, you could have done this in one step. Okay. So once you get good at this, you'll just say, oh, I have to go 2 steps there. We know it's a million. But just for this first problem, and let me just show you how that works out. If I multiply these two fractions together, just those two, okay, we'll multiply the rest of it later, just those two, we'll see what happens. We get, let's do the numbers first. 1,000 times 1,000 is a million. And I'll put the commas in there so you can see there's a million. All right, that takes care of the number, just a numerical value. And then for the units, I've got a megabyte here and a megabyte there, and those 2 megabytes are going to cancel. Okay. Now, what remains from the units is that kilobyte. That's unbalanced. We're just looking at this, and you'll see that that kilobyte doesn't cancel in there. Okay, it will when we multiply the whole thing, but right now we're just looking at those two parts. The kilobyte doesn't cancel, all right, and the gigabyte doesn't cancel, and so we get the kilobyte in the numerator not canceling, and we get the gigabyte in the denominator not canceling, like that. Okay. There you go. Now, when you get good at this, you're not even going to do this step. What you're going to do is you're going to say, oh, gigabyte to kilobyte, right? Because that's what the problem is, right? Over here, gigabyte to kilobyte, all right? I say, oh, well, that's 2 steps, and 2 steps is a million, right? It's 1,000 thousands, which is a million, okay? Now, look at what happens here. Now that we multiply this whole thing out, magic is going to happen. See that gigabyte there? In the numerator, it cancels that gigabyte in the denominator. And that kilobyte in the denominator cancels that kilobyte in the numerator. And all the units cancel out, which is what you expect, because the answer is a number. It's not a size. It's not an information size. It's just like a number, like how many files will actually fit on there. Okay, and so all the units are going to cancel out. That one cancels that one, and that one cancels that one. And so now we get just the numbers here: 8 divided by 600 multiplied by 1 million. Like that. Okay. And now be careful because, make sure you know how your calculator works. This is going to be, you do the 8 divided by 600 first, and then you multiply by the million, okay? Otherwise, don't do 8 divided by 600. Don't do the multiplication of 600 times a million first. You'll get a totally wrong answer. You do the division first, and then once you got the answer to that, you do the multiplication, okay? And let me just do that very quickly on my calculator here. And I get this number here, which is way too many decimals. There's no such thing as 0.3 of a file, and so the answer is just like that, okay? And so I threw away the fraction because, like I said, there's no such thing as a third of a file, okay? So the answer is 13,333. So you can fit 13,333 40-page docx papers on a, what did I say, 8 gigabyte drive, okay? Now, whenever I say drive, by the way, I mean like either a USB drive or a USB stick or a hard drive on a computer or the storage. It's actually called flash storage, but there's a storage on your phone, okay? From the old days, we tend to call them drives, but they really are storage units, okay? That's a better name for them, but because everyone uses that word, I'm going to use the word drive, okay? It's shortened from hard drive. All right, so there you go. That answers that question. All right, let's do part B of that problem. Okay, and part B of the problem is how many 300-page papers in PDF format could you fit on this drive? Okay, and let's we're doing this together, so my language isn't totally clear. On a test, I'd be totally clear. I would say assume that the 8 gigabyte drive is completely empty. Okay, so it's all free space. All right, so once again, we're going to be using this formula right here. Right here. All right. But we don't know the size of one file right now. Okay, we do know the size of the device, but what's the size of one file? Okay, so I guess I could say, well, what's the size of the free space? That part we know. All right, that part is the 8 gigabytes. I just give you that. But what's the size of one file? All right, we don't know that. Let me put some tabs in there so it's all right, like that. What's the size of one file? Well, it's a 300-page book. Okay, so it's 300 pages. And now you ask, how big is each page? All right, and we go back to this chart over here. So we go back and we say, all right, we're looking at a document. All right, a book is a kind of a document. And we're looking at it, and we now have to ask the question, well, what's the format? Because that makes a big difference. And the format is PDF, okay? And one page of a PDF document is 100 kilobytes. Okay, it's 100 kilobytes per page. So down here, we're going to say, okay, yeah, it's 300 pages, but it's 100 kilobytes per page, like that. All right, so you can see that already I'm making one of these fractions. One page is equal to 100 kilobytes, so 100 kilobytes per page. That's another meaning to the word per. Okay, rates tend to fractions. These kinds of ratios tend to cause some problems in our minds. But whenever we say per, that's kind of what we mean. We mean these kinds of fractions that are equal to 1. Okay, so here it's 100 kilobytes per one page. Okay, and so now we could just multiply that out, and we'll get 300,000 kilobytes. Okay, now you could certainly leave the answer like that. Okay, 300 kilobytes. But like on a test, if I were just asking you the size of one such book, okay, you would, in its multiple choice, I would not give you the answer as 300,000 kilobytes. And the reason is that I always want the numbers to be bigger than 1, but less than 1,000. Okay, in other words, I want to adjust the metric prefix such that the number always comes out between 1 and 1,000. And this one's too big, because it's 300,000. You go, well, how does that work? So what we want to do is we want to convert it to the next metric prefix. Now that's easy. You just divide by 1,000 and bump it up. But we'll do it as one of our fractions because why not? Okay. And so here's our fraction. We want to get rid of the kilobytes. Okay, because kilobytes are too small. The number is too big because the unit is too small. And we want to go to the next unit up, and the next unit up is megabytes. Okay, and I'm not going to jump up to that chart because you really should have that chart memorized in your head. And you can just say, oh, 1 megabyte is the same as 1,000 kilobytes. Okay, and now you could see here you're using kind of the inverted of the fractions that we used above. Okay, above we had 1,000 divided by 1. Here we have 1 divided by 1,000. And what happens is the kilobytes will cancel and you're left with megabytes. Okay, so that's the unit here, megabytes. And the 300,000, okay, I'll get rid of that, gets divided by 1,000, so there's the number. Okay, and that gives you an answer of 300 megabytes. Okay, yeah, that's right. Did I do something wrong? No, I did. It's fine. That's fine. Okay, so 300 megabytes. Okay, so each book is about 300 megabytes. I did do something wrong. I'm sorry, guys. I'm sorry. So that should be 300 multiplied by 100 is 30,000, not 300,000. Okay, sorry about that. Okay, so right, because 300 times 100 is not 300,000, it's 30,000. Okay, so right, 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Okay, so 300 pages multiplied by 100 kilobytes per page is 30,000 kilobytes. Okay, but we want to convert that to megabytes, and so 30,000 divided by 1,000 is 30 megabytes. Okay, and there's our answer. So one book, one PDF book of length 300 pages is about 30 megabytes in size. All right, there we go. All right, so let's move on now. We haven't quite answered the question, because the original question was how many of these books could you fit on an 8 gigabyte drive, and we started with this fraction, and we have the top part, but now we also have the bottom part, the denominator. Okay, so we could go back to this like that, and we could say, okay, so the size of the device is 8 gigabytes. Okay, and the size of one file is 30 megabytes, like that. All right, let me indent that so we can see it as part of the same question. Okay, and you say, oh, I'm in one of these situations again where I have gigabytes and megabytes. All right, and the units are mismatched, so you can't just divide 80 by 30. You got to fix the units first, and you say, all right, we got to go from megabytes to from gigabytes to megabytes, and you just say here, okay, we want to eliminate gigabytes, so we'll put them in the denominator. And we also want to eliminate the megabytes, put them in the numerator. And 1 gigabyte is the same as 1,000 megabytes, all right, from that chart. And now, if you look at all the units, the gigabytes will cancel and the megabytes will cancel, because your final answer is just a number. It's like so many, okay? And a number like 5 or 10 or whatever, it doesn't have units. Okay, a measurement has units, but just like a number, like a whole number, doesn't have units. Okay, so what's this going to equal? Well, it's going to equal 8 divided by 30 multiplied by 1,000, like that. Okay, and let me see what that works out to on my calculator. It works out to this number here, like that. Okay, so my calculator is giving a lot of numbers there, a lot of decimals, but there's no such thing as a fraction of a book. Okay, and so we're just going to dump that fraction, and we'll say 266 books. Okay, so that's the answer. The answer is that there will be you can fit 266 books, and these are 300-page PDFs on 8 gigabyte storage. All right, that answers that question. Okay, let's continue. All right, here's part D. How much space is left over on your 8 gigabyte drive if you have 100 of those books? Okay, so this is a little different. And this is more, I'm trying to get more realistic now. Normally, you don't fill up your entire USB drive with just books, okay, with just PDF books. You're going to have some PDF books on there. Then you're going to have some papers. You might have some other stuff. And so we don't need 266 books to fit on this USB drive. We could fit up to 266. We're only going to need 100. Okay, so this is an 8 gigabyte USB drive, pretty old because we're up to about 64 right now, even 128. Okay, so you've got this 8 gigabyte USB drive, and you only need to put in 100 books. And how much space is left over? Okay, so just use your intuition here. So what's the size of 100 books? Well, that's just going to equal 100 times 30 megabytes. Okay, because it's 30 megabytes, so it's 100. Actually, we can make it as a fraction. It's 100 books, okay, but it's 30 megabytes per one book, like that. Okay, and so this is going to equal 3000 megabytes. Okay, 3000 megabytes, like that. All right. Now, again, I don't want to just leave it in this format, because remember that number there should be bigger than 1 but less than 1,000, and we're at 3,000. And so if it's not between 1 and 1,000, what do? You use your metric prefixes until you get it in that range. Okay. Now, 3,000, we want to convert it to the next metric prefix up, would be gigabytes. So we want to eliminate the megabytes. So we'll put them in the denominator so that they cancel. Numerator here, denominator there. And we want to eliminate them in favor of gigabytes, okay? Why gigabytes? Because that's the next unit up, okay? So remember, it goes kilobytes, megabytes, gigabytes. Gigabytes are the next biggest one. And so 1 gigabyte, if you look at that chart, is the same as 1,000 megabytes. And basically, this is going to give us 3 gigabytes, okay? Personally, I would just have looked at that and go, oh, 3,000 megabytes is the same as 3 gigabytes. Because you know that every time you bump the metric prefix up by 1, you divide the number by 1,000, okay? So this number went from 3,000 to 3, that divided it by 1,000. And so the metric prefix has to go from mega to the next bigger one, which is giga, all right? So 3 gigabytes. That's how much the books take up. All right, so if the books are taking up 3 gigabytes, and the entire device is 8 gigabytes, how much is left over? Well, I think it's pretty obvious that it's 5. Okay, so size, or free space, like that, is going to be the total space minus used space. Okay, I mean, I think that's pretty obvious, but if you want to memorize formulas, that's just another formula there. And the total space is 8 gigabytes, and the used space is going to be 3 gigabytes, like that. And if we subtract the 2, we're going to get 5 gigabytes free space, like that. Okay, so that's how much space is left over after you've put 100 books on there. Okay, and let's answer the last question of the series. All right, before we move on to the next one. How many movies can you fit in the remaining space? Okay, in other words, how many movies can you get into that 5 gigabyte of free space? Well, let's look at that chart up here, the chart of the typical sizes. Okay, right here. And you can see that the typical size of a movie is 4 gigabytes. And so if we go down here, we could just say typical size of a movie is 4 gigabytes. Free space is 5 gigabytes. And I think it's pretty obvious that the answer is just 1. Okay, so you can only fit 1 in there. Just 1 movie in there. All right, and there you go. That answers that question. Okay, so you can imagine something like this. You have this old USB drive, 8 gigabytes, and you've got a whole bunch of PDF books. 100 of them is a lot. It might be all the books that you need for your entire career. Okay, student career, and you put them on this drive, and then you say, well, I still got some space left over. It would be enough for, say, a high quality 2-hour, say, lecture. So you've got a lecture, it's 2 hours long, like the lectures that I do on YouTube. 2 hours long, high quality, you could only fit 1 on there. Okay. By the way, if you download movies from YouTube, they're compressed quite a bit, and so they're significantly smaller than 4 gigabytes. Okay, but then they're low quality. Okay. Okay, that answers our first question, and I tried to make this question as realistic as possible. Imagine that you got a 8 gigabyte USB drive, and you ask the question, "Is this enough for all of the information I'm going to need for my career here at in college?" And the answer is depends what you want to put on it. So, if you're looking at your papers and you say, well, I'm going to have to write these papers, and a 40-page paper is quite a long paper. I mean, most classes don't demand that you write 40-page papers, but if you said, well, I have to write these 40-page papers and store them on this 8 gigabyte USB drive, how many would I be able to get on there? And that's 13,000. And I think you would agree that 13,000 papers is inhumanly possible. Okay, you could not write that many papers during your entire career in college. Okay, and so this USB drive, that gives you a sense that it could accommodate a lot of papers, so much that you can't possibly fill this thing up with just the papers that you're going to write. Okay, and then you might say to yourself, but I also have to have space for these textbooks, because I'm getting these textbooks in PDF format. I know we still buy physical textbooks, but you can get textbooks in PDF format. And you say, well, how many of these textbooks could I get on there? And 266 books, and these would be fairly big PDF files, because remember, we did an estimate of 100 kilobytes per page, and that's like something, maybe a physics or math textbook might be up there, but lesser textbooks might not be even that big. So, but safely you could get 266 textbooks on there, and you're going to say, well, I'm not going to need 266 textbooks. I doubt you would even need 100. I said 100 in this problem, but you probably won't even need that. So yeah, that 8 gigabyte drive would be more than enough to be able to accommodate all the textbooks that you're going to need. Okay, and then there would still be space left over, not only accommodate your textbooks, but it would also be able to accommodate the papers that you're going to write. Okay. And then you say, okay, well, you know what? I also want to start recording lectures. Okay, and I want to record all the lectures at Juvo College, and how many lectures could I get on there? Okay, now you got to watch it. It depends. If you do really high quality, you could do a fairly low quality lecture, and it may not look that good, but still, you'd be able to get the information that you need off of it. All right, but if you did do high quality lecture or video recordings of lectures, then you'd only be able to get like maybe 2 hours on there. Okay, because a 2 hour movie is 4 gigabytes, and with the remaining space you'd only get one. But if it were totally empty, 8 gigabytes, you'd be able to get two 4 gigabyte movies on there. In other words, you get about 4 hours of video recordings, and that's not enough. Okay, so this gives you a sense of the size of these devices. Okay. And 8 gigabytes is a little bit small. Like I said, that's like an older one. Nowadays, you can get 64. But you know what? You could just redo this problem and scale everything up by a factor of 8. Okay, and that's how much you'd be able to get in there. Okay, let's continue with our next problem here. Our next problem is more along the lines of what you would have with a laptop. Okay, so when you buy a laptop, of course, it has a hard drive in it. Okay, and the hard drives are typically 2 terabytes in size. Okay, and you might ask the question, well, how many movies could I get on a 2 terabyte drive? Okay, so let's do that one. So remember, it's the formula is how many. I'll abbreviate the formula a little bit. How many? Okay, and how many is free space divided by size of one file, like that. Okay, and now we have 2 terabytes of free space. Okay. In part A, I'm just going to assume that the entire drive is available. Okay, and we're going to divide that by the size of one file. And we're talking movies here, so whenever I say a movie, I mean like a 2-hour video. All right, and so 2 hours is like 4 gigabytes if you look back at that chart. Okay, typical sizes, 4 gigabytes like that. And you take a look and you go, oh, I've got terabytes in the numerator and gigabytes in the denominator. I need to fix that. So we want to get rid of the terabytes. Whoops, terabytes are like that. So we want to make sure that the terabytes cancel, and we want to convert to gigabytes. And a terabyte is bigger, so 1 terabyte is 1,000 gigabytes, like that. Oh, yep. good. 1,000 gigabytes. And you'll notice that all the units cancel out. Terabytes will cancel terabyte there, and gigabyte there will cancel gigabyte there. So if you just get the numbers, you'll have 2 divided by 4 multiplied by 1,000, and that's equal to 500 movies. Okay. Is that enough for all the lectures that you would ever want to record at Duval? Yeah, it's getting pretty close to that. Okay, so if you really had a 2 terabyte drive completely free, and you wanted to record every single movie, like a full recording, not just audio recording, but a full recording, you'd be able to get 500 movies on there. Okay, that's a lot. All right, that's a lot. And so to give you an idea of just how much that is, I ask in the next question, how many days of viewing is this? Okay, and so this is actually a prelude to the data rate problems that we're going to be doing in a minute. But this has a question of time. So remember, these are 500 movies, and each movie is 2 hours long. And so that's 1,000 hours. Okay. Now you say, well, 1,000 hours, how many days is that, right? So let's convert from hours to days. All right. Let's actually use HRS as the abbreviation for hours. And so we could do this using one of our fractions, but now it's not a fraction for a metric prefix. This is going to be a fraction for time. Okay. And we want to eliminate hours. Okay. So we'll put the hours in the denominator. So hours here in the numerator, hours in the denominator, so that they cancel. And we want to convert that to days, because that's what I ask, how many days. Okay, and you say, okay, well, I need some numbers in here to make that equal to 1, and 1 day is equal to 24 hours, like that. And you'll see now that the hours cancel and the only remaining unit is days. And if you work that out, that's going to equal 125. Oh no, 1 second. 1,000 hours, let me just do that on my calculator. 1,000 hours divided by 24 is this number right here. Okay, 41.66666 days. Okay, well, we can just round that off to roughly 42 days. All right, so that's 42 days of non-stop viewing. All right, so when we did this conversion, we're assuming that we're just going to be watching one movie after another. Okay, I don't know when we'll have time to sleep. Okay, but we're just going to watch one movie after an hour, and that would turn out, those 500 movies would turn out to be like 1,000 hours, and 1,000 hours is like 42 days of nonstop viewing. Okay, and so that gives you a sense that there's an awful lot of information on that 2 terabyte drive. Okay, and it would probably cover all the lectures that you would ever attend at Duval College. I don't know how you could process that information if you try to watch it that quickly. You probably can't. Okay, that's why we have lectures, and then we have breaks, and then you have more lectures. You need some time for your brain to assimilate that information. But if you collected them all, you'd be able to fit them all into this 2 terabyte drive. 500 movies, 500 2-hour lectures. Okay, now. This is not very typical that you have a laptop and the full 2 terabytes is free. Okay, and we'll see later when I do operating systems that when you buy a computer, even if it's a fresh computer, it has this hard drive in it, and the hard drive is maybe going to be a quarter full or something like that with the operating system, okay, and some other files that it needs in order to run properly, and the rest of it's going to be free. But it's going to have some information in it. Okay. Now I'll show you how you can check how much free space you have on your laptop late in another lecture. But typically you'll have like 3/4 free or maybe half free, something like that. It depends on how much stuff you've already put on it. But in this next question, I'm going to assume that you have a 2 terabyte drive, but it's only 1/4 free. Okay. And so now we're going to be doing this formula again. Say this formula right here, which is how much free space divided by the size of one file. But now things have changed a little, because the free space isn't the full 2 terabytes. It's 25% of 2 terabytes. You say, well, how do I do that? Well, first, convert the 25% to a fraction or a decimal. Okay, and so this is going to be 0.25 multiplied by 2 terabytes, like that. Okay. Now, if you multiply 0.25 times 2, that's going to give you 0.5 terabytes, like that. Okay. Now, there's more to the problem, but if this was the only question that I asked on a test, like what's 25% of 2 terabytes, you wouldn't see, my tests are like multiple choice. You wouldn't see 0.5 terabytes as one of the answers. And the reason is that because all the numbers should really be between 1 and 1,000. Okay, and you say, well, how do I get that number between 1 and 1,000? And the way you do it is by changing the metric prefix. Okay, adjusting the metric prefix such that the number is always between 1 and 1,000. If you're over 1,000, you keep dividing by 1,000 and changing the metric prefix until you're less than 1,000. And if you're below 1, then you keep multiplying by 1,000 until you're within the right range. Okay, so here we've got terabyte, and terabyte is too big a unit. Okay, that's why we're getting a number which is smaller than 1. So terabyte's too big, so let's go to the next smaller one. The next smaller one is gigabyte. So let's convert from terabyte to gigabyte. So we form our fraction here, and we want to put terabyte in the denominator because we want to eliminate it. Here it is in the numerator, denominator, and we want to go to gigabyte, so we'll put that in the numerator. And then you say, okay, the bigger unit is a terabyte, so 1 terabyte is the same as 1,000 gigabytes, like that. Okay, and now the terabyte is going to cancel out. All right, and it'll be left with a gigabyte, and so you'll have the numbers, which is 0.5 times 1,000 gigabytes, or 500 gigabytes, like that. Okay, so that's how many. That's how much free space you have. That doesn't answer the how many, but at least that tells you the upper part, which is the free space. Okay, so how many is going to be 500 gigabytes? And we're going to divide by the size of one file. Well, we're talking about movies, so we've got 4 gigabytes here. Okay, and now we don't have to worry about converting because got gigabytes in the numerator and the denominator, they'll cancel out. And 500 divided by 4 is 125 movies. Okay, so let's write that in English. So if we have only 25% of 2 terabytes free on our hard drive, you can fit 125 movies. All right, and again, this is more realistic because what's going on there is you've got other stuff on your hard drive, and so you only have 1/4 of it free, and you could fill in with 125 movies. 125 movies, or 2-hour lectures, however you want to think about this, that's quite a bit. That's quite a bit. Okay, so all right, that answers that question. The last question was more aimed towards phones. Okay, so on a phone, one of the things you do on a phone is you will surf the internet, and when you go from one web page to another, most of what a web page is are images. Okay, now these images, they download to your phone so that you can view them, and they get stored temporarily in what's called the web cache. All right. Now, eventually they'll get cleared out of the cache. Your phone does that, behind the scenes. But if you go from one page to another, it'll stay. Those images will stay on your phone for a while, so they accumulate in this temporary storage area. And you might wonder, well, do I have enough space on my phone? Like how many of these low-quality images could I fit? And so let's do that question. Okay. And again, I'm going to assume that the phone has only 8 gigabytes of storage, and it's 25% free. Okay, I could have done a different fraction, but you get the idea. Now, 8 gigabytes is a bit small for a phone. My old phone was 8 gigabytes. My current phone is 16 gigabytes. Okay, but better phones will have like 32 or even 64 gigabytes of memory. Notice that phones are in the gigabyte range for storage, whereas laptops are in the terabyte range. And terabyte is 1,000 times bigger than a gigabyte. So what this tells you is that your phone is about 1,000 times smaller. Well, maybe a bit more than less than that. Say 500 or maybe 250 times smaller in storage than your laptop, and that's why you can fill up phones a lot faster. Especially if you put a lot of apps on phones. I'm sure everyone's experienced this. You fill them up with apps, and then it says, "Well, I've got no more space to install another app, remove some apps. Okay, my current phone is only about 11% free. Okay, and that's typical because I don't have a lot of apps, but they get filled up pretty fast. And then I've got, I take pictures, it gets filled up with high quality images and so on, which is actually my next question. Okay, so how many low quality pictures can you put in there? So let's go back to the chart up here, this chart right here. And let's take a look at the low quality images. So low quality images are web images. Whenever you hear me say web images, think low quality images. They're about 100 kilobytes each. Okay, so 100 kilobytes for a low quality image. All right. High quality, I can't tell you. I got to tell you the number for the high quality, the size of a high quality image. Because high quality, the sky's the limit. You can always go to higher and higher quality. But low quality, if you go below a certain threshold, then you start the image doesn't start to look good. Okay, so about 100 kilobytes is that threshold. If you go below 100 kilobytes per image, the image is not going to look good to humans. Okay, you could squeeze it down to really small. You can keep compressing it and smaller and smaller and smaller. But about 100 kilobytes is where you start to notice that the quality has dropped. Okay, so most web images are about 100 kilobytes in size. Again, approximately. Okay. So that's the number we're going to use here for the size of the file. So once again, we have free space, okay? And the free space now is going to be 25% of 8 gigabytes, okay? And so you just take 0.25 and multiply it by 8 gigabytes, and that gives you 2 gigabytes, okay? Basically a quarter, okay? So that's the free space, all right? So if we do this formula right here, how many web quality images can you get on there? The free space, that's going to equal 8 gigabytes. And the size is going to be, of each image is 100 kilobytes. Okay, now you take a look at that and you say, okay, I've got to convert the units because I've got gigabytes in the numerator and kilobytes in the denominator. And you say, well, how do I do that? Well, we want to get rid of gigabytes, so we'll put the gigabytes in the denominator here. Okay, and we want to go to kilobytes up here. Okay, now if you take a look at that chart, there's no direct conversion between gigabytes and kilobytes, but we've done this already, and we've done it a few times, and you realize that you go from gigabytes to megabytes first, and that's a factor of 1,000, and then you go from megabytes to kilobytes, and that's another factor of 1,000. So you're doing two metric prefix changes, and each one brings in a factor of 1,000. So again, giga to mega is 1,000, then mega to kilo is 1,000, and so 1,000 times 1,000 is 1,000,000. Okay, so 1 gigabyte is going to be 1,000,000 kilobytes. Okay, if you can't see that, then you do it in the 2 steps, and you'll get just 1,000 from one fraction, 1,000 from the other. But I think you should be good enough that you could do this in 2 steps, and you realize again, giga to mega 1,000, mega to kilo another 1,000, for a total of 1,000,000. Okay, so our conversion fraction is that one. 1 gigabyte is equal to 1,000,000 kilobytes. And notice that the gigabytes will cancel. Okay, and the kilobytes will cancel. And this is going to equal, basically, I'll just give you the numbers, 8 divided by 100 multiplied by 1,000,000, like that. Okay, and let me do that on my calculator. Oh, I'm sorry. I made a mistake. The free space is not 8. It's 2. Okay. It's 2. So that's 2 gigabytes. Yeah, I apologize. So that was the free space here was supposed to be 2 gigabytes, not 8. Okay. And so that's going to be 2 divided by 100. And let me see what that turns out to be. I'm glad I caught that mistake. And that's going to be 20,000. Okay. That's a lot of images. Okay. That's a lot of images. So you'd be able to get 20,000 images on your phone, low quality web images. Okay, so let's just finish that off by saying, so you can get 20,000 low quality images on 25% of 8 gigabytes of storage. All right. Okay, just to give you an idea of how much 20,000 images are. Like imagine that you viewed just one image per second. How long would it take? So this is not part of the question, but just to give you an idea, like how long would it take to view all 20,000 images. Imagine you view 1 image per second. Okay, then you would be viewing for 20,000 seconds. Okay, and you say, well, what is that in hours? Well, we can do first. We'll convert from seconds to minutes. Okay, so seconds are here in the numerator, so put it in the denominator here. And so we'll go to minutes. So 1 minute is 60 seconds. Okay, but that's not going to be enough. We'll also convert from minutes to hours. So minutes here in the numerator, so put minutes in the denominator there. And we're going to go to hours like that. And 1 hour is 60 minutes like that. You could have done it in 2 steps, but you know that it's going to be more than just like 60 minutes. So might as well convert it to hours right away. And if you do this, your seconds will cancel, your minutes will cancel, and you're going to end up in hours. And so you'll get 20,000 multiplied by 1 divided by 60, multiplied by 1 divided by 60 like that. And that's going to equal, let's see here, do that on my calculator, 5.6 hours. So it's a lot. It's doable, but you wouldn't want to do it. Imagine just like viewing one image after another, click, 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 once a second. You'd have to go for over 5.5 hours before you'd watch them all. Okay, so your phone, even if it's like an old phone with 8 gigabyte storage, and if it's only 1/4 free, you could view a lot of web pages, okay, before you start to fill up that storage. Okay, now most pictures that you take are going to be higher quality than just web page images. Like in a lot of phones, you can take a picture and you get an image. Okay, now I don't know if they'll be 4 megabytes in size, but 4 megabytes is a really high quality image. Okay, this is the kind of image that you would get like if you bought a camera, like an SLR camera, a single reflex lens camera, and most of those images are like really high quality images. They'll be in the roughly 4 megabyte range. Okay, and now you might ask the question, well, how many of those higher quality images would you get on the phone? Okay, and so we're still using this formula here. Okay, and I apologize, I used 8 before I caught my error, but it is 2. Okay, so the free space is 2 gigabytes. It's 8 gigabytes total space, but only 25% of it is free, so it's 2 gigabytes, and each image is 4 megabytes in size. Okay, and again, like if I tell you it's a high quality image, I got to tell you the size, because the high quality doesn't give you, there's no limit to how high the quality can be. The low quality there is, for again, because you can tell if it gets too low, but the high quality is no limit. So on a test or in an assignment, I would say high quality image, and I would tell you the size just like that. I would say 4 megabytes like that. Okay, and so you take a look at this and you go, the units are mismatched again, and we want to go from gigabytes to megabytes. Gigabytes are in the numerator here, so put them in the denominator there, and we want to go to megabytes like that. And which one's bigger? The gigabyte. So 1 gigabyte is 1,000 megabytes. Okay, again, from that chart you should have memorized, and you'll notice all the units cancel. Gigabyte cancels gigabyte there, megabyte cancels megabyte there, and if you do that, you'll just get the numbers. So you get 2 divided by 4, okay, from the first one like that, and from the second fraction here, you just get 1,000 like that, and so that's half of 1,000 or 500 images. Okay, so you would get 500 images of size 4 megabytes in 8 gigabytes of storage. That is 25% free. All right, so there you go. That answers our question. Okay, and 500 images, that's still a lot of images, but these are high quality images. Okay, all right, now having finished that, the next thing that we're going to work on are data rate problems. All right, so data rate problems are going to be problems where we are looking at how fast information is transferred over the internet or over whatever transfer we have. Okay, it's usually over the internet. Okay, so the reason we want to study these kinds of problems is because you're going to go out and you're going to be getting some kind of a internet package from like Spectrum or Verizon or one of these companies. Okay, and these companies, they have different technologies for bringing the internet to your home, like either cable technology, which can also feed your cable TV, or it could be fiber optics, like with Fios through Verizon and so on. And they limit how much bandwidth you get. Okay, now what does this word bandwidth mean? What does it mean? It's actually the rate at which information can be transferred to you. So if you've got a particular technology and they say, you're going to get 100 megabits per second download speed, what does that mean? Well, what it means is that in 1 second of time, there's going to be 100 million bits of information that'll travel through that line from the internet to your computer. Okay, so there's a few things to notice here with this word megabit. First of all, mega, you know what that means, million. Secondly, it's bits, not bytes. Okay, so when we talk about days of size problems, we're usually talking about bytes, almost always. Okay, as you see, all my previous problems, everything was in terms of bytes. Okay, but remember, 1 byte is 8 bits, and when you go to buy data rates, you don't buy them in bytes per second, you buy them in bits per second. Okay, and it's usually megabits per second. So what that word megabit per second means is mega means a million, bit means a 1 or a 0 per second. Okay, so if your line is 100 megabits per second, it means in 1 second it's going to be able to download 100 million bits from the internet. Okay, that's the download speed. These packages have both a download speed and an upload speed. The download speed means the speed at which information from the internet comes to you. Okay, and that's your download speed. The upload speed is the rate at which information can go from you out to the internet. Now, usually you're worried about like maybe watching a movie off of Hulu or something like that. And so you're more worried about your download speed because that's the rate at which the information is going to get to your computer. But you might also be worried about upload speed. For instance, right now that I'm going to upload my video, I'm doing this video on my computer, I got to upload it to YouTube. Well, if my upload speed is slow, that means that the upload of that video is going to be really slow. Okay, and so for that reason, upload speeds are of interest. Okay, later on when we talk about the internet in greater detail, I'm going to talk about peer-to-peer technology. And in peer-to-peer technology, you're simultaneously downloading a file as well as uploading a file. And if you're doing both at the same time, you're worried about not only your download speed, but also your upload speed. Now, with cable, usually the upload and download speeds are different. Okay, and I think my current speeds at my house are 100 megabits per second download, but only 10 megabits per second upload. Okay, which is kind of annoying because it means it's kind of slow for me to upload things. But it doesn't bother me that much because I tend not to be uploading as much as I'm downloading. Okay, but for some people, especially people that do a lot of peer-to-peer stuff, and again, we'll talk about what peer-to-peer means, your upload speeds are of interest too. Okay, so when you buy these packages, you want to look at both the upload speed and the download speed. Okay. Now, almost no speed today is slower than a megabit per second. Okay, so these are going to be in I don't think you'll ever get even under 5 or 10 megabits per second. So these, the rates are going to be in the megabit per second range. But you could have kilobits per second. Okay, and you also have and in the future you might have even gigabit per second. Okay, so we got to understand what those numbers mean. Okay, and so here I kind of wanted to give you a sense of what a megabit per second is. Okay, so let's start off at the lowest possible level with a bit per second. Okay, so what does that mean? That means if you say something is a bit per second and the unit is written as BPS like that. So if you say you've got a bit per second, what that means is that this this internet line would only allow the transfer of 1 bit every second, one 0 or 1 1 every second. Okay, as you can imagine, this is extremely slow. Not very slow, extremely slow. Okay, because you need 8 bits to make a byte, and 1 byte is 1 letter. So that means that it would take at 1 bit per second, it would take 8 seconds to transfer just 1 letter from the internet to your computer. Okay, and that's insanely slow. Okay, never did we have internet speeds that slow. Even like in the 80s when the internet used to go through phone lines, believe it or not, the old landlines. Okay, uh, so 1 bit per second, it means that basically it takes 8 seconds to transfer one letter. Okay, so ridiculously slow, but at least a benchmark in your mind. Okay, the next one is the next metric prefix up would be kilo. And so you might ask the question, well, how fast is a kilobit per second? Okay, well, that basically means that you're transferring 1,000 bits every second. All right, now 1,000 bits, that's like 125 bytes per second. All right, so 125 bytes per second means 125 characters per second, because again, if we're talking ASCII, 1 byte is 1 character. And that's not too bad, if you're just doing text, because a typical text message is, I think, like around 125 bytes. When you write a text message on your phone and you transfer that, you're transferring, roughly 125 characters, and that's 125 bytes. And if your internet only allowed 1 kilobit per second, you'd be able to transfer 1 text message per second. Okay. If you were just texting, you could live with that. But we don't just text, okay? We actually do a lot more than that. We do multimedia, all right? So back in the days when, computers were purely just text devices, and we're talking like late 80s, early 90s, when I would connect to the computers at Cornell, I would do that through a phone line, and it was literally just letters going back and forth. I would type on a screen and I'd see letters come back on the screen. Okay, just ASCII on the screen. Yeah, it was tolerable. You could live with that. But today, this would be intolerable. Okay, because we want much more than just one text message. We want to do much more than just a text message, or even a text message per second. Okay, so when we get up to a megabit per second, okay, what does that mean? Well, a megabit per second would mean 1,000,000 bits per second. Okay, now 1,000,000 bits, if you convert that to bytes, would be 125 kilobytes. All right, so 125 kilobytes per second. All right, now if you think about what 125 kilobytes, you say, well, what's about 125 kilobytes inside? Well, about 100 kilobytes is one image. One image. Okay, so if your internet were 1 megabit per second, it means you'd be able to transfer 1 image per second. Okay, well, this is getting barely tolerable if you want to surf the internet, because a web page is generally made up of maybe like 5-10 images or something like that. Okay, now there's a lot more to modern web pages than just images, but just imagine like some old school web page that was just like images and text. Okay, the text is pretty small, but if you had 5 images, that would mean 5 seconds to load that web page. Okay, and if it were a really interesting web page, you might have 10 images. That would be 10 seconds to load that one web page. All right, and nowadays web pages have much more than just images on them. They have like little movies. Okay, you can see like even on the Juval homepage, there's a little movie up at the top. Okay, it isn't a static image, and that's even more. Okay, that's even more data. Okay, but if we had to live at 1 megabit per second, basically each web page would be about 5 seconds to download. Okay, and that would be kind of annoying, especially for the way we're used to working with the internet. Once upon a time, you had to live with that, and people were like, okay, I got to wait for this web page to download. But nowadays, how do you surf the web? Click, 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 click. Like you look at the web page, you barely spend any time really reading it. You just determine, is this the web page I want, or do I want to go further? And then you click another link and you go to another web page, and you go to another web page, and go until you finally find the information that you want, and then you pause. But if you're spending like fractions of a second on a web page, or if you only want to spend fractions of a second on a web page, this is way too slow. Way too slow. And so it would absolutely annoy you to live at 1 megabit per second. As I said, today, you're about 10 megabits per second for my upload speed. That is like the absolute bare minimum. Anything less than that would just be intolerable. But more typically, most internet speeds are in the 100 megabits per second. Okay, and when you've got fiber optics, because fiber optics is a better technology than cable, at fiber optics, you could easily get up into the hundreds of megabits per second, and then beyond megabits per second, if you get up to 1,000 megabits per second, well, 1,000 mega is a giga, and then you're into the gigabit speeds. Okay, a gigabit per second. And once you're in the gigabit speeds, I mean, basically you could have no problems downloading movies and so on. In fact, I've got some problems like that. Okay, now before we actually jump into those problems, there's actually two formulas that you need to learn here. Okay, so here they are. The first formula is to answer questions how long. Okay, so if I say to you, how long does it take to download this movie? How long? All right. Then the way you want to solve those problems is you take the size of the file, all right, or the size of whatever it is that you want to download, because it might be more than one file. You just take the total size, all the data that you want to download, and you divide it by the rate. Okay, so if you do size divided by rate, that answers questions about how long it takes to download something. Okay, but there's another type of question that you might want to ask, and that's how many. The how many question. And the how many question basically is a question like this, like how many movies could I download if I downloaded nonstop for a week? Okay, how many movies could I download? Okay, and for those kinds of questions, basically what you do is the rate divided by the size. So it's kind of the opposite. All right. So in these problems, you want to determine first, am I trying to answer how long does it take to download something, or am I asking how many does it take, can I download in a given amount of time? All right, and depending on which question you're trying to answer, you're going to have two different ways of doing it. Okay, the units for how long will come out in seconds. Now we might want to convert that to hours or days or whatever. Okay, but yeah, that's the how long. The units will be seconds before we convert. And for the how many, you'll actually get units, and they'll look weird because it'll be like per second. You'll go, well, what does it mean per second? 1/2 is read per second. Maybe I should just write that down here. That's read per second. And you mean, what is that? Well, you might want to change that unit too, but that's how many files you download per second. Okay, so, and it could be a fraction of a file, as we'll see. So there's two types of units here. Okay, so two more things before we jump in to the problems. First, careful. The rates are in bits, not in bytes, and so we'll often have to now convert bytes to bits and vice versa. Okay, and the other careful thing, it's not really careful for solving the problems, it's just something to be aware of when you actually buy these data rates. Okay, so you get a bandwidth of 100 megabits per second. You say, well, am I really going to get what you're doing in these problems here? And the answer is probably not. Okay, and the reason is that when they sell the bandwidth, they actually sell it at up to 100 megabits per second, and that means that at any given time you might actually be getting less. I said a little less, but sometimes you might get a lot less than 100 megabits per second. And you might say to yourself, well, I'm being cheated. What's going on here? Well, what's going on is that, especially with cable, that the cable line is feeding an entire neighborhood. Okay, and so if everyone is using the bandwidth at the same time for that particular neighborhood, it tends to cut down on other people's bandwidth too. That's not so much the case with fiber optics, but it is the case with cable. And so if everyone is competing for the cable at the same time on the neighborhood, like now it happens within your house, but I mean even between houses, if everyone's competing, you can get less than the what they advertise for you. So the reason I mention that is because you could actually do these problems and calculate how long it would take to download a movie based on the speed of your bandwidth, and you discover that you're not getting the full bandwidth, and you're going, well, what's going on? And what's going on is that you might be competing at that given time. If you're ever wondering what your bandwidth is, you don't have to ask your company, like your cable company or Verizon for Fios. Okay, you can actually go to various websites to measure your bandwidth. I mean, an old website that I used to use is called DSLreports.com, but there's lots of them. Just Google for measure bandwidth or measure my bandwidth. Okay, and there's lots of these different companies. And you could choose any one of them, and it's best to use a bunch of the different ones because they'll give you different answers, and they'll tell you, what kind of bandwidth you're getting. Okay, and they'll give you both the upload and the download speed. Okay, with that out of the way, let's start with our first problem here. Okay, so here's our first problem, and I've got two parts to it. How long does it take to download a 4 gigabyte movie at 50 megabits per second? Part A, and then do it again, but at 50 megabits per second. Okay, so look at the units here. So BPS is bits per second, and that's how usually how it's written even on like the websites for like Spectrum or Verizon or all of these companies, okay, BPS. And then the M in front, that's your metric prefix, mega, okay, megabits per second. All right, so we take a look at this problem, and it's you first identify, is it a how many or is it a how long? And it's a how long. So basically we're going to be using this formula right here. How long does it take to download this movie? Okay, and let's start off. The size is like the total amount of data that you're going to download. Okay, like how much data you're going to download. Well, we're downloading one movie. How long does it take to download a 4 gigabyte movie? Okay, so I tell you it's 4 gigabytes. So there's your size, 4 gigabytes. Okay, now the rate, this is the part that gets a little trickier. Okay, so the rate is the 50 megabits per second, and we're going to write that down here for the rate. And you look at this and you go, well, how do I work with these units? Okay, so here I've got giga and mega. That part we know how to deal with. The byte, we kind of know what the byte is, but what's this BPS, this bits per second? Okay, now the way to do this is write down 4 gigabytes here and 15. We'll actually put brackets around this, 15, and the P here is per, okay, and per means divide. And so immediately write this unit in this form here, megabits per second, like that. Okay, megabits per second. So you see that I converted that P to a division sign like that. All right, now what? Well, we're almost there, but what we have here is a unit which is actually a fraction. Okay, and so we've got the bigger fraction here, you know, the numerator divided by the denominator, but then within the denominator we've got another fraction. And you go, well, how do I deal with that? So you know, just to remind you a little bit of like some mathematics, a little bit of algebra. If you've got a fraction that looks like this, okay, so that's like a divided by b divided by c, like that. You say, well, how do I divide by a fraction? Well, dividing by a fraction is like multiplying by its reciprocal. Okay, so this can be written as a times c divided by b. What did I do? Rather than dividing by b divided by c, I multiplied by c divided by b. Okay, so what's the relationship between b divided by c and c divided by b? They're reciprocals. Okay, so if you divide by a fraction, that's like multiplying by its reciprocal. All right, so you should know that from, like, I don't know, your probably grade 9 or something like that. Okay, but we're going to use that with this fraction right here. Okay, and so the best thing to do here is isolate the numbers first. So you got a 4 and a 15. So we got 4 divided by 15. We'll just make that, we'll just put the numbers aside because that part is easy, 4 divided by 15. Okay, and now for the units, we've got gigabytes here in the numerator. And then for that one, because we're dividing by that fraction, we're going to multiply by its reciprocal. Like that. Okay, so what did I do there? That was megabits per second in the denominator, and that becomes seconds per megabit in the numerator. Okay, that's the hardest part in solving these problems right there. Okay, so basically that was in the denominator, now it's in the numerator, but it's the reciprocal. I did exactly this here. Okay, now what? Well, the way to think about this is there's the giga part and the mega part. And then there's the bytes part and the bits part. The seconds part, that doesn't cancel against anything. So we can actually just put the numbers here for a second. We can put the seconds by themselves, okay? And then we can actually just put gigabytes divided by megabits here like that, okay? Put this off to the side because this is the part that we need to untangle a bit more, okay? To do this, the problem here is that we have bytes and bits. To take care of this, we need to make use of the fact that 1 byte is equal to 8 bits. Okay, that's one fact that we're going to make use of. The other fact that we're going to make use of is that 1 gig is equal to 1,000 megs. Okay, now before I said megabyte here, and gigabyte here and megabyte here, okay? But right now, I'm not even worried about whether it's bytes or bits or anything like that. I'm just looking at the prefixes. And the prefixes, if you want another way to think about them, is they're just numbers. Like giga is just a billion. Mega is just a million. So you know what this says? A billion is just 1,000 millions, or 1 gig is 1,000 megs. Okay. Now the reason I had to separate them like that is because we've got two things going on here. We got the gigs and the megs, and we got the bytes and the bits. Okay. So on the next line, what I'm going to do is I'm actually going to separate this even further. This part we're not worried about. This part we're going to have the gig divided by the meg, like this, and we're going to have the byte divided by the bit. Okay. So when we get good at this, you don't have to go through all these steps, but we got, the gig divided by the meg and the bits divided by the bytes. Okay. Now what does this mean? Well, the gig divided by the meg, well, a gig is 1,000 megs. Okay. We could do the fraction, but I think it's kind of clear that this number is going to be 1,000. Why? Well, because a gig is 1,000 megs. Here, I can do it in 2 steps. We've got gig divided by meg. The gig I can replace with 1,000 megs like that. Okay, so I just took the gig and replaced it with 1,000 megs, and then the megs will cancel and leave me just with 1,000. And then the bytes divided by the bits, I've got this, but now I can write that. Let me put some spaces in here. It's a little easier to see. Okay, the byte here I can write as 8 bits. Why? Because there it is. Okay, and then I've got bit divided by bit, and they'll cancel out. Okay, so notice what I did. Gig divided by meg is 1,000 meg. I just took the gig and made it into 1,000 megs. So gig divided by a meg is just going to be 1,000. And a byte divided by a bit, well, a byte is 8 bits, so that's just going to reduce to 8. And so now we're going to get, leaving this part alone, okay, this just reduces to 1,000. This reduces to 8, like that. That reduces to 8. And what we've got is all the units are resolved except for the seconds there. Okay. And now what I can do is I could just take, let me just collect all the units, the numbers together. So I've just got this multiplied by this, like that. Okay. And then seconds at the end. All right. And what's this going to equal? Well, let me do that on my calculator. There it is. And too many digits, so I'll just round it off to that. There it is in seconds. Okay. So how long would it take to download a 4 gigabyte movie over a 50 megabit per second line? 266.7 seconds. Let's convert that to minutes. Okay. So to convert it to minutes, you would just multiply by minutes on top, seconds on the bottom, right? To get rid of the seconds and introduce minutes. And 1 minute is 60 seconds, like that. And so basically just divide 266 by 7. Let's see, by 7 I mean by 60, and it gives you 4.44 minutes, like that. Okay. All right. So there's our first problem. Let me just do that number again. Make sure I got this right. I think I might have made a mistake. Hold on. Oh, I did. I apologize. Hold on here. So this is just doing this on my calculator. I get this. And let me just round that off into seconds. Okay. And so that does answer the question. It would take 2,133 seconds to download a 4 gigabyte movie over a 50 megabit per second line. But let's convert that to minutes. Okay. And so over here we have seconds. So we want to get rid of seconds and go to minutes, like this. And 1 minute is equal to 60 seconds, like that. Okay. And that's going to equal, well, the seconds go away. All right, so it's just like dividing by 60. And that tells me, that gives me 35.6, let's round that off, 35.6 minutes. Okay, so a little over 30 minutes. Okay, so it takes 35.6 minutes to download a 4 gigabyte movie over a 15 megabit per second line. Okay, all right, so there we go. Now I have a part B, which is 50 megabits per second. And the reason I want to do it again is it's the same process, but I really want to make sure that you understand how this worked in here, because I think a lot of students make that mistake. So let's do it again. We'll do it a little bit faster, but make sure that we understand what's going on with those units. Okay, so the size is 4 gigabytes, and for part B, it is 50 megabits per second. Okay, so 50 megabits per second. So over here, divided by 50 megabits per second. Okay, now the unit written like that is a little bit confusing, so it's the same number again, but we'll write it as a fraction. So the P part, that's just divided here like that, megabit per second, like that. Okay, now let's isolate the numbers. So we got 40 divided by 50. Okay, so I'm just isolating the values here. And now let's isolate the units. We got gigabytes in the numerator. We got a fraction in the denominator, but it becomes the reciprocal in the numerator like this. Okay, so megabits per second in the denominator becomes seconds per megabit in the numerator. And then let's, we still have that 4 divided by 50 here. Let's put the metric prefixes together. Okay, so we've got G divided by M. All right, and let's put the bits and the bytes together. We got B divided by little b. All right, that's in the numerator, that's in the denominator. And then the seconds, that's just going to go along for the ride, like that. Okay, so there's still that number. We'll work it out in a minute. Giga divided by mega, that's 1,000, right? Okay. All right. Why? Because a gig is 1,000 megs. All right. And the bit divided by the byte, that's 8. Why? Because a byte is 8 bits. All right. That's 8. And then there's the second. And let's work out that number. And that number turns out to be 640 seconds. Okay, let's convert that to minutes. So 1 minute divided by 60 seconds, like that, is going to equal a little over 10 minutes. Let's see. Whoops. 10.7 minutes, like that. Okay, so it takes 10.7 minutes to download a 4 gigabyte movie over a 15 megabit per second line. All right, and that answers part B. Okay, now I should say something at this point about this business of downloading. All right, when you're actually watching a movie online, okay, so here I said download. The idea of downloading is that you're going to store it on the hard drive. You might actually store it on the hard drive and then watch it later. But a lot of times we actually watch the movie as it's downloading and then throw it away, because how many times, why store it if you're just going to watch it once? Okay. Or you might watch it a few times, in which case you would want to store it. But a lot of times we just want to watch a movie and throw it away as we're doing it. That's especially true of a YouTube video. Most YouTube videos, you're just going to watch them once. Why put them on your hard drive first and then watch them? Just watch them embedded in the web page. Okay. Now this is called streaming. And what streaming means is that you watch it at the same time as it's downloading. Now, streaming only works if it downloads faster than you can watch it. Okay? And so the question might be, can you stream at 15 megabits per second? Can you stream a high quality DVD movie at 50 megabits per second? Can you stream it at 50 megabits per second? And the answer is yes, at both of them. And the reason is 4 gigabyte movie is how long? 2 hours. It's 2 hours long. Well, even at 15 megabits per second, okay, that movie would download in about half an hour. So a 2-hour movie, you could download it in half an hour. That means it downloads faster than you can watch it. Okay, and that means it's streamable. If, however, the line were a 1 megabit per second line, it would be 15 times slower than this. So it would take 15 times longer to download it. Okay, so if you calculate that, all right, if it takes 35.6 minutes at 50 megabits per second, then it's going to take at 1 megabit per second, it would take 534 minutes, and that's 8 hours. And so that's not streamable. And again, the reason is you've got this 2-hour movie, but it takes close to 9 hours to download it. So you can imagine a 2-hour movie being stretched over 9 hours. That's not going to work. Remember, streaming means that as you download it, you throw it away. So it has to download faster than you can watch it. This would be downloading slower than you would have to watch it, and that means that it's not possible. Okay, and so there's a certain threshold. Okay, and that threshold is above that threshold you can stream it. Faster than that you can stream it. Okay, but slower than that you can't stream it. And what will wind up happening is because the line isn't perfectly uniform, if you were below this threshold, it would buffer a bit, and so you'd watch it for a little while, and then it would stop, and you get one of those spinning wheels where you're waiting for more data to arrive, and then it would play for a little bit more, and then you get one of the spinning wheels and so on. Even at 15 megabits per second, even though you can stream it at that rate, you might have problems because remember, it doesn't stay at a steady 50 megabits per second because you're competing with other people for the bandwidth. It might go down, dip down, and come back up. And so every once in a while, when your bandwidth slows down for whatever reason, it might not be enough for you to be watching it at that rate. And then what it has to do is it has to stop. It has to wait until enough data arrives, and then it can continue playing from there. And this happens a lot with YouTube. Now, it's not your bandwidth that's causing the problem with YouTube. What's causing the problem with YouTube is that at their end, their bandwidth is getting eaten up. So it's not only your bandwidth, but it's their bandwidth too. Okay. All right, that answers that question, and it gives you a little bit of insight into what streaming is. Let's go on to our next question. Our next question is, how many high quality JPEGs, 5 megabytes each? Okay, so remember when I tell you an image is high quality, I got to tell you how big it is. So how many high quality JPEGs? A JPEG is a kind of an image, as opposed to like a bitmap, which is another kind. So there's different types of image formats. And these JPEGs are 5 megabits in size. How many of these can you download in 15 minutes over a 20 megabit per second line? Okay, now this is a different kind of question. So first of all, I'm asking how many of these things can you download in 15 minutes? This is the time period over 20 megabits per second, and that's the rate. Okay, and you realize that you're no longer doing a how long problem, but you're doing a how many problem. They're related, but over here, remember I introduced how many, you need to do this formula here. Okay, so for how many, it's going to be the rate divided by the size. Now there's actually 2 steps to this. When you just do this division, you're going to get how many per second. Okay, but I don't want to know how many per second. I actually want to know how many in 15 minutes. So you actually answer these questions in 2 steps. You answer first how many per second, and then you answer how many in 15 minutes. Okay, so let's do this. You'll see that things are a little bit different, but enough similarity. The rate is 20 megabits per second. Okay, and the size of one file is 5 megabits, like that. And so that's what we want to divide. Okay, and as you can see, you've got a mismatch of units. You've got megabits per second in the numerator and megabytes in the denominator. Okay, so let's first write the megabits per second as a fraction. Okay, so this is going to be megabits per second. Okay, so we write p like that, but really that p is a division, like that. It's a fraction, and then all of that is going to be divided by 5 megabits. Okay, and I find it easy in these problems to just first isolate the numbers. Okay, so we've got the 20 and the 5 there, so let's put those together. So we have 20 divided by 5, like that. And now we have this fraction divided by that. Now, in this situation, your fraction looks like this: a divided by b, and then all divided by c. Okay. Notice that the fraction is not in the denominator, it's in the numerator. And so you don't have to flip the fraction the way we did above. Just to remind you what we had to do above. Over here, we were in this situation where we were dividing by a fraction. And dividing by a fraction is like multiplying by its reciprocal. So we flipped it and then we multiplied by that. But here, we're not dividing by a fraction. We're just dividing by another quantity, okay? And to do this, both B and C are in the denominator, and so this just looks like A divided by B times C, okay? So both B and C are in the denominator. So in this case, we have megabits in the, that's like your A, we have that in the numerator, and we have both seconds and megabytes in the denominator. And so over here, we're going to write megabytes and then seconds, okay? I flipped them around because the seconds are the only part of the unit that are going to survive, okay? Now, the next thing is we didn't have to do this for the data size problems, but for these data rate problems, I find it easiest to just collect together the metric prefixes. Remember, the metric prefixes, the best way to think about them is they're just a number. So when you say mega, that's just saying million, okay? Like, I don't know, like mega eggs. A funny example, mega eggs would be a million eggs, okay? Megabyte is a million bytes, megabits is a million bits, okay? Megameter would be a million meters, okay? So megabyte, the word mega by itself just means a million, okay? And so we have a million on top and a million on the bottom, all right? So both the numerator and the denominator. And so they'll just divide out. That's like dividing a million by a million, okay? So let's leave the 20 divided by 5 alone. Okay, and let's just collect together the metric prefixes. So we got mega divided by mega there, like that. And that's pretty much trivial because that's equal to 1. Okay, basically that's just like saying what's a million divided by a million? Well, a million divided by a million is 1. All right, now here we have bits divided by bytes. Okay, so we'll put those together. So bits is in the numerator, bytes is in the denominator, like that. And then we have this final unit here, seconds, but that seconds is in the denominator, and so we'll put it by itself. We'll do 1 over second. Okay, now that unit might look funny, but that's what it is. The seconds is in the denominator, in the bottom, like that. In the previous problem, seconds turned out to be in the numerator, but here it's in the denominator. Okay, and we'll see how to interpret that in just a minute. But let's simplify this. Well, the mega divided by the mega, that's easy. That's just 1. But what's the bits divided by bytes? Well, remember that 1 byte is 8 bits, okay? And so the byte here, the capital B, I'm just going to replace it with 8 bits, okay? So this is equal to, leave that alone, okay? The mega divided by mega, that's 1, okay? And then the bits divided by byte, like that, you could just take that. Let me spread it out here, put some spaces in there. You could just take that byte there and replace it by 8 bits. Okay? And then we still have the per second, like that. Okay? So here, I just took the byte there, replaced it by 8 bits. And now you'll notice that a bit divided by a bit, that cancels. And so this entire fraction just becomes 1 over 8. Okay? And so that's the next step. Over here, we get that. And then we get 1 divided by 8, like that. And we still have the per second as our unit, like that. Okay. Now, up above, we had a byte divided by a bit. It was the other way around. Let me show you that. We had a byte divided by a bit. And a byte divided by a bit, remember, a byte is bigger. A byte is 8 times bigger than a bit. So if you have something which is 8 times bigger than the bottom number, that's going to give you 8. There are 8 bits. In other words, 8 little bits can fit into a byte. Okay, but here we in this problem we didn't have bytes divided by bits. We had bits divided by bytes, and a bit is 1/8 of a byte, and that's why we're getting 1 over 8 here. Okay, so I hope that helps you to understand, like how to interpret, this fraction here. All right, and now what? Well, now we can just, do this number here on our calculator. Let me do that for you very quickly on my calculator, and that's equal to 0.5. All right, so it's 0.5 per second. And you go, what the heck does that mean? What does that mean, 0.5 per second? Let's read the question again. How many high quality JPEGs can you download in 15 minutes over a 200 megabit per second line? I didn't quite answer this question. I answered how many you can download in 1 second. let's just write that in, even though I didn't ask that. Let me just write that in English here. So you can download half an image. Now, why did I say half? Because that's what 0.5 is. In 1 second. That's what this means. Okay, so students sometimes have difficulties interpreting what these fractions mean and per second mean. The 0.5 means half an image, and the 1/2 means per second. It means you're downloading half an image per second. Okay, so you're downloading half an image per second, so you can download 1 image in 2 seconds. Okay, or 2 images in 4 seconds. Or 3 images in 6 seconds. Okay, basically every second you don't download half an image. Okay, so like in this one, what's going on? In the first second, you got 4 seconds. In the first second, you download half an image. In the second second, you download another half image for a total of 1 image. In the third second, you download another half, and in the fourth second, you download another half. So half and half from the first 2 seconds is 1 image. Half and half from the second 2 seconds is another image. So for a total of 4. Okay. So in for a total of 2 images in 4 seconds. All right. So that's how you interpret this. Okay. Now we don't want to do it for 6 seconds, 4 seconds, or 6 seconds, or whatever. We want to do it in 15 minutes. And you go, well, how do you do that? Well, you just say, how many seconds are there in a minute? In 15 minutes. How many seconds are there in 15 minutes? Okay. And to do that, what you do is you do basically a conversion. All right. You convert from minutes to seconds. Okay. Now we could do that separately because I asked this as a separate question, but I think it's easier to just do this. The rate is, or actually it's not the rate exactly, it's the how many. The how many is half an image per second, and you say, but I don't want it half an image per second. I want it in 15 minutes. So we want to convert to 15 minutes like this, like how many per 15 minutes. Okay, and the question here is, what number would I want to put here such that this fraction is 1? Okay, well, we could do it first for 1 minute because I think that's easier to understand. Let's do 1 minute first. Okay, well, 1 minute is 60 seconds. Okay, and again, I put the seconds in the numerator so that it cancels the seconds in the denominator. And so right now I could say I'm downloading half an image in 1 second, or if you multiply this out, you're going to get 30 images per minute. Doesn't that make sense? If you get half an image per second and you do this for 60 seconds, then you're going to get 30 images. So you're downloading 30 images per second. And you say, that's still not what I wanted. I wanted it for 15 minutes. And so you could say, okay, we're going to take this 30 images per minute and we're going to do it for 15 minutes. And that's going to equal 30 times 15. And that's 450 minutes, images. Okay, so basically in 50 minutes you would be able to download 450 images. Again, you know, if you want to see this another way, 15 minutes, if you multiply that by 60, that is 900 seconds. Okay, so 15 minutes is 900 seconds, but you only get half an image per second. So, you know, you have to divide that by 2. That gives you 450 images. Okay, once again, like in the first second, you only get half an image. In the next second, you get the other half of that image. Okay, so 2 seconds per image. How many 2-second intervals are there in 900 seconds? 450, so you get 450 images. Okay, so I talked you through that quite a bit. Okay, if I were just doing this, you know, what I would do is I would start right here, like, you know, without all the extra explanation in there. I would do that, and then you know, I would do substitute in the fraction here like this. Okay, and then you know, doing the unit analysis there, that would get me down to half an image per second. Okay, and then at this point I would say, but I want 15 minutes, so I would do this 60 seconds in 1 minute, and I would say, but I don't want 1 minute, I want 15 minutes. So I would multiply both the numerator and the denominator of that fraction by 15. And you can do that because this fraction is equal to 1. So if I multiply the numerator by 15 and I multiply the denominator by 15, you're still 1, because if you do the same thing, the numerator and the denominator, they'll cancel out. And then this would equal, again, the 450 images, okay? The seconds would cancel out, all right? And you would get 450 images in 15 minutes like that, okay? And that answers the question. Let's write that in English. You would be able to download 450 images in 15 minutes. Okay, so I agree these are the hardest kinds of problems, these how many per unit time, but there it is. Okay, and we'll do one more of those, and then that'll be enough for our rate problems. Okay, so actually, you know what, let's do number 4 next. Okay, because it's another one of these rate problems. Okay, so we'll come back to number 3 afterwards. So at 30 megabits per second, how many movies can you download in 1 week? Okay, so let's read that again. At 30 megabits per second, how many movies can you download in 1 week? Well, you identify that this is a how many problem. Okay, and so over here, we start with that, how many. Okay, and the rate is 30 megabits per second. All right, so 30 megabits per second. And the size, well, we're downloading a movie. We're downloading movies for it's 4 gigabytes per movie. Okay, and now we got to do that unit analysis. The first thing I would do is right here, I wouldn't even write down the per. I would just put a divide like that. So we have in the numerator megabits, and in the denominator we have seconds and gigabytes. Okay, so isolate the numbers, 30 divided by 4. Isolate the metric prefixes, mega and giga. All right, mega and giga. Isolate the bits and bytes, bit divided by byte. And the only remaining unit would be second in the denominator, so per second. Okay, now what? Well, we have 30 divided by 4 here. And here we could do the kind of like fraction conversion that we've been doing, but I'm going to do it a slightly different way. This might help you to understand what these metric prefixes are all about. Mega is synonymous with a million. Okay? And giga, that means the exact same thing as a billion, and a billion is 9 zeros. Okay, like that. So mega divided by giga is like a million divided by a billion. All right, and the bit divided by a byte, well, a bit is 1/8 the size of a byte. So this is 1/8, like that. Whoops. Let me spread that out so it's easier to see. Okay, remember, a byte is 8 bits, and so that's like 1/8. All right, and then there's the per second unit at the end there, like that. Okay. And finally, if you just work this out on your, actually, let me just do one more step here. That's equal to this. A million divided by a billion is like 1 divided by 1,000. Okay, and then there's the 1/8, and then there is the per second. Okay, the reason I wanted to do this is I wanted to make the connection with the table. Mega to giga. Giga is 1,000 megas. Okay, and so we get that. All right, let me work that out on my calculator. And that gives me this number right here. All right, now we're not done with the problem, but let's just stop right here and ask, what does this mean? That's a tiny number. And you say, well, why am I getting this tiny number? And the reason you're getting a tiny number is because that's the fraction of a movie that you download in 1 second. So it's that much of a movie per second. Okay, well, you would expect, even at a 30 megabit per second speed, you would expect that you'd only get a fraction of the movie every second. That doesn't answer the question, because I said how how many can you download in a week? It's like nonstop downloading of movies for 1 week. Okay, why you'd want to do that, I don't know. But let's suppose you did. Okay, well, if you only wait 1 second, you only get a fraction, but then you get another fraction. You get the same fraction, and then you get the same fraction each second. Each second, you get the same fraction, and then that adds up. Okay, and so that's how many you get per second. But now you want to ask the question, well, how many will I get in a week? And let's do this by these conversion fractions. First, let's convert from seconds to minutes. Okay, so seconds in the denominator here, so we have to put seconds in the numerator. Well, we know that 1 minute is 60 seconds, and so this fraction is equal to 1. But we're not there yet. We've gone from seconds to minutes. Now we want to go from minutes to hours, because that's the next unit up. Okay, and we know that there are 60 minutes in 1 hour. But we're not done yet. Let's go to the next unit up, which would be a day. And so we would do hours divided by days, like this. And we know that it's 1 day is 24 hours, like that. Okay, but we're still not done, and I'm running out of room here. Let's see if I can fit it in. Or maybe I can just do this. We're still not done yet, because the next one is we want to go from days to week. Okay, and whoops, I got them upside down. Day and week, like that. And how did I know I had it upside down? Well, because day here is in the denominator, so I want that in the numerator. And we know that 1 week is 7 days. And so what I've done here is, let me squeeze that in. Okay, there we go. What I've done here is I've basically done a whole bunch of conversions to get from a second to a week. Okay, like you may not have this number in your head. I don't know who would, how many seconds there are in a week. If you did, you could make this all one fraction. But rather, what I did was I said, okay, well, I have it in per second. Let's go per minute, and then let's do it per hour, and then let's do it per day, and then let's do it per week. Okay, so each one converts to the next unit up. Okay, and now let's see what that's equal to. So this I have to do on my calculator. So let's see, it's times 60 to get it to minutes, times 60 to get it to hours, times 24 to get it to days, and times 7 to get it to a week. And it turns out to be 567 movies per week. Okay, so in answer to the question, how many movies can you download in 1 week? 567 movies. All right, so that's the first part. All right, and let's do the second part. Okay, the second part asks, part B, it's down here. Part B says, at 1 megabit per second, how many movies could you download? Now, we could redo the entire thing, but let me just show you what happens right at the beginning. Okay, here, instead of having 30 like we did here we had 30 megabits per second. Okay, instead of 30 megabits per second, all right, like that for the previous problem, in this problem we have 1 megabit per second. Okay, now 1 megabit per second is a 30th of this. So in other words, this is 1/30th slower. Okay, you could go through all the same math that we did above, and basically all you would get at the end is 1/30th of this number here. So you don't really have to redo the entire problem. All you can do is you could just say the answer is going to be this, but this is at 30 instead. At 1 megabit per second, it would be a 30th of the speed, and that's going to equal, let me do that on my calculator, divide that by 30, 18.9 movies per week, which is not that much. Okay, but well, it's still, for viewing it's a lot, but it's a lot less. So if you're wondering, what did I just do here? Why did I just divide by 30? Well, let's go through the previous problem here. So here we had 30 megabits per second divided by 4 gigabytes. And so here we had 30 divided by 4, 30 divided by 4, 30 divided by 4. We get this number, and then it works out to this. But now, instead of 30, we have 1. If you continued, everything like the next line would be exactly the same line here, like that. whoops, not there, but here, it would be the exact same line. But now, instead of 30 here, we would have 1. In other words, each line would be 1/30th of the previous line, okay? So you could see that you didn't have to redo the problem because this is 30 times faster than that. And so you would expect that this would download 30 times as many movies as that. Or another way to think about it is that this would download 1/30th of the movies that would download in the same amount of time. And so rather than redoing the problem, you just realize in your head, well, if that's what happens at 30 megabits per second, it must be 1/30th of that at 1 megabit per second. Okay? And so let me just put the two statements side by side. You can download 567 movies in 1 week at 30 megabits per second, okay, like that. And down here, the similar statement would be, down here, would be you can download 18.9 movies at 1 megabit per second. Well, let's just put these two statements side by side, okay? Take a look at the two statements, all right? So over here, this speed is 30 times faster than that speed, okay? So you get 30 times as many movies as you do at the slower speed. That should make sense. Just think about driving a car. If you're driving 1 mile an hour, 30 miles an hour, you're going to travel further in the same amount of time at 30 miles an hour than at 1 mile an hour. In fact, you're going to travel 30 times further in the same amount of time at 30 miles an hour than at 1 mile an hour. And that's exactly the same thing here. And in fact, when we say speed, you know, the word speed means a few different things to our minds. One idea of speed is how fast you're going with a car. Another idea for speed is the rate at which you download data. And you say, well, how are they both the same speed? Well, this is how. Okay, so really, when you talk about the rate, 30 megabits per second, you're saying at what speed are you downloading? Okay, and if you're 30 times faster, you're going to get 30 times as much data in the same amount of time. Okay, 1 week in this case. All right, so I just want you to start thinking about these problems intuitively. I kind of showed you formally how to solve the problems, but think about them intuitively. Finally, I skipped number 3. I didn't want to skip it. I just wanted to do the two how many problems together. Let's do number 3. Number 3 actually turns out to be a how long problem. Okay, so if you download continuously at 50 megabits per second, how long would it take to completely fill a 2 terabyte hard drive? It's a little bit different, but it's still one of these how long problems. And for how long, you want to do, so how long, it's the size divided by the rate. Okay, so how many is rate divided by size? How long is size divided by the rate? Well, the size doesn't mean necessarily the size of file. It might be just how much data you want to download. Okay, well, the question was, you want to completely fill 2 terabytes. Okay, so if you want to completely fill a 2 terabyte drive, that's your size. So over here, the size is 2 terabytes. Okay, the rate is 50 megabits per second, like that. Okay, and let's write the megabits as like that. All right, so as a fraction, megabits per second. Okay, now here we're dividing by this, which is a fraction, and so let's put the numbers to the side first, like that. So it's 2 divided by 50. Next let's collect together the metric prefixes. Tera divided by mega, like that. And we've got the bits and the bytes here, so a byte divided by a bit. Okay, byte divided by a bit. All right, and then the seconds in the denominator of the denominator just becomes seconds on the line, like that. Okay, so maybe I just should have showed you one more step in between. Let me just show you that. Collecting that together, we would get that. Then in the numerator, we have the terabytes there. But because we need the reciprocal of that, we're going to have seconds on top and megabits on the bottom, like that. And then I collected the terabytes and the megabytes together, and the bytes and the bits together, and the seconds is on in the numerator, like that. Okay, now The next thing is, let's resolve these units here. So just the metric prefixes, tera divided by mega. You see, how do you do that? So this one's a little bit harder because now we're into the gigas, billions. Now we're into the trillions, and you might start to lose track of you know how many zeros you need in there. Well, let's go back all the way to that metric prefix right at the very beginning here. Okay, so we had this. So let me just copy and paste these. Okay, so we're going from tera to mega like that. Okay, we're right here. All right, so just as an aside, let's write this down like that. Okay, so we've got this and that and that. Okay, so let's take a look here. From tera to giga, we got a factor of 1,000. Okay, so that's 1,000 just to go from tera to giga. From giga to mega, we've got another 3 zeros. We got another 1,000. We could put some commas in there to see how this goes. Okay, so from tera to giga, that was the first 3 zeros. From giga to mega, that's the next 3 zeros. And we're not quite there yet. Oh yeah, we are actually. I'm sorry, we don't have to go to kilo. There we go. Sorry about that. I was about to go one step further, but we don't have to. Tera to giga, 1,000. Giga to mega, 1,000. So tera divided by a mega is 1,000,000. Okay, so this number here is 1,000,000. Like that. All right. Once again, because I'm kind of like taking a shortcut here. Tera to giga gives you 1,000. Giga to mega gives you another 1,000. And so tera to mega is 1,000,000 or 1,000,000. All right. And so that's where this number comes in. And then we got bits divided by bytes. Now a byte is bigger than a bit. It's 8 times bigger. So this number is just 8. Like that. Okay. And then we have the seconds there like that. Okay. So again, that's like 8 bits. So 8 bits, a byte is 8 bits. The bits cancel and you just get 8 in there like that. Okay. And then finally, I'm going to just do this on our calculator. And we get that many seconds. Okay. Now, the question was, if you download continuously, how long would it take to completely fill a 2 terabyte drive? That's how many seconds, but seconds are annoying. So let's convert it first to minutes. And here we have seconds in the numerator. So we want seconds in the denominator and we want to convert it to minutes first. Okay. And 1 minute is 60 seconds like that. Okay. And then we want to go from seconds to, from minutes to hours, because this is going to be more than an hour. Okay. And so, we got minutes here in the numerator, so we want minutes in the denominator. Okay. And then we'll be in hours like that. And so 1 hour is 60 minutes like that. And let's see what that turns out to. We might want to go one more step, but let's just see where we're at there. Divide that by 60, divided by 60, and yeah, we want to go one step further because this gives me 88.9 hours. Okay, and you might say, well, how long is 88.9 hours? It's definitely longer than a day, so we can convert this down to days. Okay, so hours in the numerator, so we want hours in the denominator here, and we want to go to days like that. And 1 day is 24 hours. All right. And so what's that going to equal? Well, just divide that number by 24 and we get 3.7. Okay. So 3.7 days. Did we answer the question? The question was, if you download continuously at 50 megabits per second, okay, how long would it take to completely fill a 2 terabyte drive? Remember the 2 terabyte drive from the previous set of problems? Okay, typical size of a drive in a laptop, it would take 3.7 days. Okay, so it would take 3.7 days to fill a 2 terabyte drive. All right. I didn't ask this, but how long would it take at 50 megabits per second? How long would it take at 100 megabits per second? Okay, so if we did the same thing again, how long would it take at 100 megabits per second? Well, if you're traveling at, I said traveling, if you're downloading at twice the speed, because I'm making the analogy in my head of driving like with a car. If you're traveling at twice the speed, you travel twice the distance in the same amount of time. If you're downloading at twice the speed, you download the same amount of material in half the time. Okay, so here, if we're going to double the download speed, we're going to halve the amount of time. So rather than it taking 3.7 days, it's only going to take 1.85 days. Okay, like that. All right. So let's see if that makes sense. See if we can make sense of that. You're downloading at twice the speed, it's going to take half the time to get to the same, to fill up the same drive. All right. So once again, what I'm trying to do is I'm trying to get you to just think about these problems intuitively. Okay, because it is kind of like a speed in a car. All right. So 50 megabits per second is half the speed of 100 megabits per second. Okay. And if you want to get to 2 terabytes at 50 megabits, it takes 3.7 days. But if you're going at twice the speed, it takes half the time. Okay. So there we go. There's not a lot of theory in this section, but there is a lot of kind of thinking in terms of ratios, okay? And if you go through these problems and think about these problems the way I did them, it should become intuitive to you, okay? I found that students sometimes have a lot of problems with ratios, and so one of the ways to get past that problem is to not only do them problems formally, like I did, in other words, go step by step the way I showed you to solve them, but at the end, try to think about the answers intuitively. And, here, like in this particular problem, I said, well, okay, if we're downloading at twice the speed, it should take half the time. Okay, so that's the kind of intuition you should use. And that intuition is good because, you're going to be using this in the real world. You're going to be, like buying an internet package from Verizon or Spectrum, okay? And you're going to be comparing packages. And when you compare the two packages, you could redo these calculations, okay? But why redo those calculations? Just, usually the packages are in ratios. And you go, well, okay, this package is twice as fast as that package, which means that, right now it's taking me, half an hour to download the stuff that I need, so that at twice the speed, it should take me 50 minutes rather than half an hour. Okay, so 30 minutes at the current speed, 50 minutes, half of that at twice the speed. Okay, those kinds of intuitions are good in the real world because you're going to be applying this in the real world. Okay, I hope this helps. Bye-bye.